Hello guys, what's up? Sean, Jordan, Justin, Daniel, Steve, hope you guys are well. Finishing off this sundown today. Beans like L-O, mate. Nice, like it. Like it. How's everyone doing today so far then? It is the evening in the UK, just had some dinner. I've been in the workshop working all day long so far today. I was working on the 100 DSM from yesterday, the Rockford Fosgate. Finally figured out the issue with that, so that's awesome. Can finally move on from that. There's one more Rockford to do, one more Rockford amplifier to finish, and then it's just the processors, which I don't know if I'm going to be able to fix, but we'll see how it goes. So the amp from yesterday was the Rockford 100 DSM. The issue with DC in the preamp was just purely the fact that the potentiometers were screwed. Look, here you go. Here's a nice little picture. So this is a good, well, this is a healthy potentiometer. This is healthy-ish. I don't know if it's 100% good or not. And then this is a dead one. So there's quite a difference there in the track, for example. And it was covered in all sorts of corrosion and stuff. So yeah, the issue with the Rockford was the potentiometers. That was the main issue anyway. There were further issues with the Rockford. The further issues were the surface mount electrolytic capacitors. They're big caps, but they sort of sit surface mount. They're aluminium capacitors, but they're surface mounted. One of those was causing one of the channels to be low audio compared to the other one, and also cause it to clip early. So that took me all day today to find. I wouldn't really recommend the TPA chips just because they're very hard to get hold of when they fail, and they're very delicate and sensitive. I'd go for something discrete, like just discrete MOSFETs and stuff like that, if I was you. So I'm just getting the driver board back into this sundown. Daniel says, I'm working on an amp where the LED lights up, the relay clicks in, but there's no life in the 494. Weird. Do you have 12 volts at the pin 12? And do you have a triangle wave on pin 5? Well, I said a sawtooth wave. Do you have a sawtooth wave on pin 5? No sawtooth wave. Daniel, do you have 12 volts on pin 12 of your 494? How's it going, Thomas? Great job today, by the way. Now, because I've been working real hard today, my little thing here, foam thing, is covered in little balls of solder and all sorts of stuff, and I don't trust it. So this is quite a big amplifier with high voltage rails. So I'm just going to whack a towel on here just as an extra layer. When we're working on the sundown. Don't particularly fancy a piece of solder shorting anything out. Okay. So, yeah, just replaced the driver card. We fitted all new drive ICs, all new bootstrap diodes, pumps. So before we fit the output FETs, one thing I always like to do is just make sure we've got consistent low side drive on all of the low side FET locations. So I'm just going to run some power cables into here and just check that we have that. What's up, BPS car audio? Okay, so power's in, let's get the scope turned on. Nice low voltage to start off with. This is a Sundown SAZ 5K, this one. So yeah, 10 volts going in, a little bit, maybe a little bit of signal, but probably not need that. Eject, low frequency, 50 volts divide on the scope. Okay, so let's first of all pulse the remote a couple of times, just make sure we've got the rail voltage in the correct position. So we've got positive rail here by the looks of it. Need a bit more current than that. Negative rail here. Yep. Cool, cool. Looks good. Negative rail, and then positive should be over this side here with these four. Great stuff. On this side as well, let's double check. Got positive rail there, no negative there anymore. It's good. Negative, negative, and positive rail over this side. Excellent stuff. So let's probe a low side gate and let's see whether we have drive. Safety glasses as always when we're doing these bigger amplifiers. What the heck, this is smudged as hell. That's a bit better. I have 12 volts on pin 12 but no sawtooth wave. If you've got 12 volts on pin 12 and check the ground pin, if you do have 0 volts on the ground pin, then you have a faulty 494, which is very rare, but yeah, that's a faulty 494. With the 494s, as long as there is 12 volts on pin 12 and as long as there is ground, 0 volts on ground, then you will always have a sawtooth wave. Nice. So we have low side drive there, low side drive, low side drive, and low side drive. Excellent. I just want to check the behavior of low side drive during power up and power down. I'll make sure that it is instant and consistent. Yep, got 10 volts, let's go up to 12 volts, make sure it's still the same. I'm just pulsing it a few times, just making sure that the we don't get any bumps or pulses. Yep, that looks good. That's really, really nice and consistent. Excellent. So let's wait for the rails to sink down and then we're going to load up some FETs. I think I saw a video a while ago of you modifying a digital volt amp meter to run on lower voltage. Is that how you're measuring power in boom or bust? Absolutely, yes. That is with one of these. So this is a cheap power meter from the likes of eBay, Amazon, AliExpress, etc, etc. Actually, this one's got a massive dent in it. That's a shame. Thanks, Brandon, for the 10, buddy. I love the sticker. Thank you very much, man. That's awesome. Thanks for your support, as always. Very kind of you, buddy. Thank you. So this is a very cheap power meter. However, these things are self-powered. So that means they will only turn on when you are giving it at least 50 volts AC, which is fine for mains powered power monitoring applications, but no good for audio because obviously you're only getting AC voltage into this meter when the base is hitting above 50 volts, of course, and below that, in between base hits, this thing is going to turn off, which is no good. So yeah, what I do is I remove the self-powering circuit or disable the self-powering circuit. I just wire in an auxiliary power supply to the processor in here so that it can run on external power and sit at 0 watts until you obviously turn your amp up and start getting some bass. There's a few ways that you can do these. You can either wire them with a voltage regulator, so you can wire it in your car to 12 volts or 14 volts or even 20 volts or probably even 30. Yeah, it's just a 5-volt reg. Or if you are plugging it in via USB, if you intend to use it with USB, then you can actually just wire a USB straight to the VCC in supply pins on the processor, because it takes 5 volts. So yeah, if you're going in via USB, then you can just wire USB straight into the circuit there, and it will work. Scraping bases, trying to make sense of how resistors work. For example, a resistor in line with an LED, lower ohm equals brighter, higher ohm equals dimmer. Yep, so basically think of a resistor. Yeah, imagine you've got a hose pipe. Yeah, you connected your hose pipe to your garden tap. You're spraying, you're watering your garden, watering your flowers in your garden. Now some waste man comes along, cuts your hose pipe in half and inserts a very thin section of pipe in line with your hose pipe. Just a really thin, so you say your hose pipe is this big, oh my man, he's inserted a piece of pipe that is actually now that big, much smaller. So now what's going to happen to your water flow out the end? It's going to be rubbish. It's going to be much lower flow, much less pressure out of the end of your hose pipe, because my man has stuck a resistive piece of copper, resistive piece of pipe in the way. So that's what a resistor is doing. The lower the impedance, the wider the piece of pipe, in metaphorical terms, to a pipe versus a resistor, and the higher the resistance, the smaller the diameter of the pipe. So by adding a resistor in line with an LED, you're limiting the pressure, in a sense, of the electricity that can get to the LED, so it will be dimmer. Alright, how's the rolls looking? Okay, we're at 0 on the positive and kind of getting there on the negative. Cool. So, fresh batch of 24N40s. These are not cheap nowadays, unfortunately. Gone are the days of these being less than £1 each. I wonder how much these cost when I first started doing repairs. Man, I'd love to know actually. I might even try and find that out. I'm just going to do a quick search on my emails actually. FDA 24N40F. Let's have a look. Let's see how cheap they were when I first started repairing. Oh no! So the first set of 24N40s I ever bought was off eBay. Damn, that was quite expensive back then, even still off eBay. Alright, let's have a look. That's not good. So I obviously didn't do that again in the future. Blah blah blah. And they were from China as well. Jesus. Right, then the first set I bought from RS Components. This was back in 2017. Guys, holy crap. The first set of 24N40Fs I bought was back in 2017. Yo. That's crazy. And that cost on these, what was the cost? Does it hey, wait, it should tell me here. Items ordered. Yep. I ordered them at 1 in the morning. Standard procedure. I was always up late repairing. Doesn't have a price on these. Okay, here we go. 18th of August. I bought 15 of them. Again, no price on this. Yeah, so, oh damn, why doesn't it show me the prices? Oh, I'll tell you why, because these aren't the invoices. These are just the order confirmations. So if I have to go to, I have to look up the order number and search that. So if I search this order number, then it will tell me probably the cost of them. Here we go. No, still no good. Yep, oh well, I've no idea how much they cost, but still interesting to see that I ordered some back in 2017. And I find it hilarious that it was at 1 in the morning as well, because that's just how I used to roll. I just used to do repairs like till like 5 in the morning. Not so much these days. Trying to maintain a healthy sleep schedule and all that tin, you know. I just switched head units in my vehicle. Now my Smart 5 keeps turning on and off when the bass hits. Is the output voltage too high on my new deck? I don't know, I haven't heard of the amps turning off. You know what it might be? It might actually be nothing to do with your head unit, kind of, in a way. What might have happened is your new head unit might have a stronger RCA output, okay? As a result of that, unless you recalibrated your gain position on the amplifier, what's now happening is more signal is getting to your amplifier, so your gain position is now incorrect. You've got your gain set way too high. So now your amplifier is trying to produce way more power than it was when you had your old head unit fitted. Thus, the voltage is dropping because your vehicle supply was just about on the limit of being enough when you had your old head unit, but now you're asking for more signal from the setup. Now your voltage is dropping under 10 volts probably at the amplifier, and that's why it's cutting out. That's my guess, at least. I have never heard or never experienced any amplifier turning off due to receiving too high of an RCA signal voltage. Just the input voltage. My scope here is a 150 megahertz scope. It doesn't need to be that high for audio work, that's just kind of what this one ended up being. How do I reduce output voltage, says Brandon. Just turn the subwoofer level down, my friend. Or just turn the gain down on the amplifier. That's probably the best option, because that's what I reckon has happened. I'm just getting the height dialed in on these. Don't want them too high, don't want them too low. Daniel, bad 494, that's very rare. Consider yourself red. It's pretty rare to get a bad 494. Maybe you should go buy a lottery ticket or something. Sam Peel, yo, got a price for me yet? Literally, man, I have no idea. I even asked ChatGPT. I am so stuck. Guys, what should I charge? So, you know my series Boom or Bust. I've been saying if you want to sponsor the series with a sponsored logo in the test cabin, then get in touch. A few people got in touch. I have no idea what to charge. Like, I don't even know the price range. I don't even know if, like, £20, 50, 500, like, I have no idea. Based on the fact that my channel isn't very big, and the videos are they're topping out at about 12k views at the moment, depending on which episode it is. Obviously, we've got multiple seasons lined up, so this is season 1. So what I'm thinking is to for the price to be per season. So if you want your logos, if you want your logo on the test cabin for season 1, it's a certain price, and then season 2 it might be the same price, or it might be more if the series popularity picks up. Now, bearing in mind we're already a little way through season 1, so I can't charge that much because there's already been like 12 episodes where the logos haven't been present. So yeah, I'm not really too sure what I should be charging for sponsored logo in the test cabin. I've been trying to figure it out. ChatGPT wasn't much help. He just kind of like echoed back to me what I already said. I was thinking something like I might just have to settle for like 50 quid. It's like a round number. It's not extortionate, and it's not like super low either. 200 pounds per logo. I think maybe if my channel has like over 400k subscribers and the videos are getting like 100k per video, maybe 200 pounds per logo would be about right. But maybe 200 pounds is a fair amount to ask. I don't know. Like, let's be honest, the reach isn't that big from these videos. Like, 8 to 12k views is not that big, let's be honest. My guy Roderick, my man Roderick has a question. I'm working on a MTX capacitor C1177 has blown in half. Wow. Do you know the value? MTX TH4000D. Let me just remind myself what that looks like. I have got an MTX Thunder donor board in the loft, but don't think it's one of these. Oh wait, maybe it is. Yep. My man Roderick, I have one of these exact donor boards in the loft for you. So keep reminding me if I forget, but once I've done a bit more on this sundown, I'll go grab it for you and I'll let you know the value, provided the capacitor is still present and good in the one that I have. But usually, if I was in your situation there, Roderick, what I'd do is usually there is at least one other circuit on the board that is like a mirror image or like a clone of the circuit that you're working on. Either it's some kind of preamp bit or some kind of drive circuit or some kind of, you know, auxiliary supply voltage area. You can usually work out the value of a component by looking to see if there's like another one of those circuits somewhere else on the board. There's not always, but often there is. What's the exchange rate at the moment for UK to US? I'm not too sure. It always used to be about 150. So $100 would always be about no, sorry, what is it? $150 would always be about £100. There was a time where it was $200 was £100. That was good times, but not anymore. Okay, height looks about right on these ones, I would say. Let's get these soldered in. Wait, is the exchange rate back at like £200 is like 154? No, it's not that way round. It can't be that way round, surely. Can't be that bad. You always got more pounds for the dollar. You always got more pounds than the dollar. Hey Google, what's £100 in USD? Literally, the Google Nest are absolutely atrocious these days. I swear they've made them worse. Honestly, since the introduction of like LLMs, Google Nest, Google Home just feels ancient. It feels clunky and horrible to use. Like since the introduction of like ChatGPT and stuff like that, I'm just waiting for Home Assistants to get on that level. I'm so done of repeating myself a million times to Google. And I even have him understand what I say, because sometimes if he doesn't understand, I'll say, what did you hear me say? Or what do you think I said? And he'll repeat back to me what I said, which is the correct command. I'll then say the command again, and he'll do the thing. Even though he heard it correctly the first time round, he just didn't do it. Oh wow, is it that bad? 125. Peak! Yeah, it's pretty bad at the moment, guys. Not a good exchange. Oh, the Ace Troubleshooter. Yo, you got a question, my man. Let's have a quick look. Yeah, by the way, guys, if you want to really grab my attention, if you've got a question, tag me, because it comes up orange in the chat, and I tend to notice it better. I do read the live chat as much as I can. I can't respond to it all, but yeah, if you've got like a proper pressing question or something that you need to tell me about the repair that I'm working on, like, hey, there's a solder bridge there, don't power it up yet, Sam, then tag me in orange. But yeah, he says, oh wait, I'm not sure what he says because I think it's gone up. Straight up kicking the nuts. How's it going, man? Good to see you here. Right, let's scroll up and see this question. Where are we at? Right, let's have a look at some of this stuff. Yeah, so Roderick, yeah, we'll get that out in a minute. Depending on the logo size, bigger logo, higher charge. Finally catch a live stream. Congrats on the recent success with the Box Sim series. Thanks very much, man. Appreciate that. Honestly, it's genius. Thanks. It's a cool season. It's going down well. It's going to bring insane numbers before long. I hope so. I really hope so. I was really planning on it being the kind of thing that brings this channel up into the sky a little bit, because my channel's kind of just sitting in the dirt for the longest time, just plodding along. Like literally, today there was a post on some of the Facebook forums, some of the Basid forums, and someone was just asking, hey guys, what YouTube audio channels do you guys watch? And out of, I think it was like 200 comments, I think there were 5 people that mentioned benefits. I was like, yo, peak times, man. So I'm hoping that the Boom or Bust brings a bit more attention my way, but I understand it, to be honest. Like, people that are into car audio, that want to watch car audio channels, want to watch build logs, they want to watch, like, you know, equipment doing its thing. My channel ain't about that. Like, I understand why people don't want to watch my channel, because it's not really got a great deal to do with car audio, apart from the fact that I tend to be repairing car audio. Boom or Bust is a bit different. Boom or Bust is kind of car audio on a scale. I think people would still rather see Boom or Bust done in full size without the scaling, but man, to do that sort of thing, the kind of costs related to that would be through the roof. So, like, yeah, it could definitely be done, but I need a unit. I'd need like constant funding. I need like some kind of, you know, proper funding for it, for all the materials. I need like, it's probably CNC machines and stuff. I'd need lots of time. It would take way longer to film. But yeah, I know that a full-size Boom or Bust would definitely be way more popular. But gotta just do what we gotta do, innit? I like the controllability of the scaled series. That you can control the variables a lot easier with it in a small scale like this. I love how people that are suggesting prices for the logo are kind of just throwing out numbers in the same way that I was in my head. Like, it's difficult, isn't it? Like, how are you supposed to know? People are like, how about 80? Like, yeah, they don't even know what currency it is either. 80 sounds like a good number. Let's just go with that. Exactly. That's the kind of problem I was running into. I was like, yo, 50 sounds like a number. Yo, we got the Italian Jesse Messi in the live chat tonight, guys. Jesse Messi says, "Boom, my bust is a sweet, Thanks, Jesse. Hope your linguine was good. Billy says, just opened up an amp with 2 chip amps inside. MA5332M. I haven't seen one of those, man. I might have to Google that data sheet in a minute. Might have to have a quick peek at that, see what's going on. That's not like the TDAs, is it? Is that like the TDA chips, or is it a bit more advanced than that? Now that a good healthy amount of time has passed, what's your opinion on the the Ace Troubleshooter? I love it. I love it, man. I love the what's he call it? The politeness. I love the etiquette. My guy here, the Ace Troubleshooter, bowls in. Yay! First time catching you live. Big up, big up, big up. Waits for like 10 minutes. Right. So now my question. Love it. Super polite, man. Appreciate it. What's your opinion on the OptiDrive 7K you fixed? Oh, that was a long time ago. Shit, man. If you're referencing one of my videos, crap, that was a long time ago. I have had my hands on the 1100. Yes, the 1D. So the 11K thing is basically 2 of the 7Ks in the same heatsink on the same PCB in full bridge in like internal strap. From memory, that's why I believe it is. It's this, and there's a SoundStream version as well. So there's a SoundStream amp that's exactly the same as the OptiDrive 11K, and yeah, it's basically the same circuit, but the MOSFETs are beefy as naturally, and it's in push-pull. There's just 2 of those circuits in push-pull. Not a fan. I don't like them. Very inefficient. Tons to go wrong. Very janky. Ancient style of Class D in there. Not a big fan of that. And also all of the drivers and stuff are all on daughter boards that are just shoved into headers, not really secured down properly. The build quality is horrendous as well. I would probably stay away. I'd get yourself a base 12K from Taramps. It's a much better amplifier, believe it or not. So there you go. It's damn near equal at this point. Sad times, bro. Oh, that is weak. Do you like to fix expensive amps versus cheap amps? Depends, really. I like to fix amps that have been well thought out, the design of them. Like, I actually quite enjoy fixing JL Audio a lot of the time, not gonna lie. Because the engineering in them has actually made it a little, somewhat friendly to work on in some respects. I like fixing generic amplifiers because I've worked on thousands of them, like just the generic Korean and Chinese stuff. I don't like fixing complicated stuff that I haven't seen a lot of. For example, Alpine. Some certain Alpine stuff is very complicated. Audisons can be a royal pain in the arse, man, and they're expensive. So I guess I like fixing cheaper ones. Just because it's easier, I guess. Like, I'm not gonna lie. Yeah, I like a challenge. I like the challenge of repair. But at the end of the day, man's got to get paid. Got to get that bread. So the easier the repair, the quicker I can get it done. The quicker I can get paid for it. So I got a quote for 900 low end up to 2500 high end depending on placement of the AD for 1000. Wait, sorry, what? I have no idea what that's in reference to. Google answering Google related questions. Oh, I see. This is for you asked it basically what I should charge. I see. Yeah, I don't think the Google thing is going to have any idea. That's a ridiculous amount of money. I think they assume that I'm some kind of TV channel. Oh god, the live chat is moving fast this evening. Yeah, man, I'll always shout you out. Your name, your user. You've been around for a long time. I remember your user from back in the day, man. You always watching my streams, so I massively appreciate your continued support, buddy. This is very true. Yes, my channel is very technical. I even believe that some aspects of Boom or Bust are too technical for the average viewer. Like, most people are going to skip through the impedance sweep analysis. People just want to skip to the results or see it booming. But I include all the technical stuff because of the percentage of people that do want to see the technical stuff is very valuable information. So. So basically, the Ace Troubleshooter, into a bit of a secret, this has been done before, just not with car audio. If you like the format of Boom or Bust, go and watch the Fan Showdown. Just type the Fan Showdown into YouTube. It's exactly the same as what I'm doing, but for computer fans, and it is fantastic, pun not intended. Doing the same thing, that's me. Yep, what's up, Miles D? Just chilling here doing the same thing. Bro, at the end of the season, how about the top 3 for the whole season get done in full scale? Yep, that was always the plan. If you have watched the first episode or the pilot episode of Boom or Bust, I do explain that. I say that it probably is not going to be the top 3 because, let's be honest, that's going to be a fair bit of money to get 3 of them built. And also, what am I going to do with 3 enclosures, like, especially random ass designs, like, I'm just going to either have to, like, set fire to them or they're not going to sell. So it's probably just going to be the winner. So the winner from each series is, sorry, for each season is probably going to get built. Yes, definitely going to get built in full size. I pray to God that it's not a massive one. No, you see, right, the thing is, because I've been having second thoughts a little bit about the way that this thing gets scored. Naturally, bigger boxes are going to be louder. Firstly, they take up more space in the cabin, and secondly, just more solidness of box is more efficient. Even if someone designed a box that was like just the entire space of the cabin just done in PLA, it's going to be louder than anything else just because it's like solid. So yeah, I'm having second thoughts about the way to score Boom or Bust. So at the moment, obviously, it's just the loudest score wins. But I think I really do need to do some kind of division or some kind of ratio of loudness against size. So the winner for Season 1 might end up just being the loudest, if I just do it that way. Or I might introduce a size factor that shifts the results slightly. Because I'm not going to lie, I'm not super excited about having to have a Tuba HT built. Like, I have no space for it at all, anywhere. The back of the van, maybe. Let's slide around. It's going to be a bunch of money in materials and labour, probably. I mean, if it was a Tuba HT, I'd probably build it myself, just to, you know, prevent extra costs. I do have, like, the best box builder, in my opinion, in the whole of the UK. I do have him lined up to build something for the finale, but naturally, he has to be paid for his time. Times are tough right now. Like, times are hard, money-wise. So if I've got the option of being able to build the winner myself, if it's not too complicated of a build, like the Tuba HT, yeah, I can build that easy. I might just build it myself, just because, yeah, it's not going to be anywhere near the quality of Harwood Acoustics, who I would have lined up to build it, but it's going to be free labour for me to do. So yeah, I'm in two minds, I don't know. Enjoy your repair videos. You taught me a great deal, man. And that's good to hear. That's the whole plan. That's the whole reason I do it. So it's really cool to hear. I'm repairing a house speaker plate amp. Can you give me some tips once I get down and dirty with the amp board? Look for vibration damage if it's a plate amplifier specifically. Don't power it up on the mains until you've been through it with a fine tooth comb. Check the resistance of everything. Any semiconductor component, whether it's a transistor, MOSFET, diode, rectifier, capacitor even, yeah, check the resistance of it. If it's a short and it's not supposed to be a short, then obviously it's bad. So yeah, just check everything. Never assume anything. Check everything. Oh heck, man! You guys are proper chatting this evening, hey? This is a Sundown SAZ 5K we've got on bench this evening, which I'm just about to power up for the first time and see whether it works or not. So could be some fireworks. If it doesn't, get the old safety glasses. No, way more advanced than the TDA chips. Oh heck, I'll check it out. Eberg amplifier repair. Yep, he does good stuff as well, man. The newer version is 10K. Model is the 11001D. Stupid as hell model naming. Okay, I have the 10K. Love it. Traded it for 3D printer. Oh, fair play. 3D printer is a lot more useful, not gonna lie. That sucks. Sorry about that, Rob H. Maybe we can get him running again. No work on the audio pipe mod lately. I have like ADHD block with it. I have like a fucking brick wall in front of it. Like I just physically can't for some reason. There's nothing hard about it as such. I just need to order some laminate wire for the secondary wind on the transformer. I just need to order the right amount of wire. In order to do that, I need to measure how much wire I need with a piece of string or something. And there's just like a lot of kind of awkward and annoying steps to get that thing finished. Like none of them are particularly hard, but I just have a mental block on it. And because times are hard at the moment and I need to get as much amp repairs done as possible, it's not a high priority on my list, and it just keeps getting pushed down the priorities list. It's actually really like it's getting to me a bit. Like I'd love to finish it, but I have like such a block for some reason. Have you got to play with the DDZ-12K? No, never. No, I would never order that thing. I'd never recommend it either. It's just such a stupidly far-fetched amount of money for something that's not worth that much. Yeah, it might be a pretty good amplifier, but it's not worth the money that they ask for. It's fucking ridiculous. It pisses me off. You should probably charge 80 to 90 quid. Okay, what I'll do then is, for the Boom or Bust sponsor logos, I will probably start at, because we're partway through season 1, I'll start at £50 or 60, 50 or 60 pounds. Then for the future season, it will start at 80 or maybe more, especially if the series blows up a bit. So I'll probably start at 50 or 60 pounds for each logo for season 1. Thank you very much, guys. I'll now go back to everyone who's asked me and let them know. Yeah, I saw that video, the Ace Troubleshooter. Yeah, it was a really interesting video that Hexabase did on that. You need more things bursting into flames. No, no, no. No thanks. That's expensive when that happens. Definitely don't want that. That's why I want the cabin sticker sponsored message. It's for box building. I could build the winner. Oh shit, not a bad idea. Sam, whereabouts are you based, Sam? Are you in the UK or are you overseas? Because if you're overseas, man, that's not going to work. I'll tell you now, the shipping on an enclosure, especially something as big as the tuber, that's going to be about 800 bucks, trust me. He's going to need a pallet. It's going to be over £1,000 probably. You can use the IR2113 as well. I think the 3 variant is a little bit higher voltage. That's about it. So give that a go. What kind of advice do you want on airported boxes, my friend? Go and get a broken down cargo van and do all the full size builds in that. That's great. where am I going to put this cargo van? You might be in America where there's loads of free space and loads of parking and loads of massive driveways. Literally, the UK is like fucking squashed in, man. Like there's nowhere. Like I would have nowhere to store that or put that outside of my house or anything like that. Unfortunately, I wouldn't be able to put that anywhere. You could award the winner the top 3 or sell. Yeah, I could sell. The problem is I would only be able to sell the full-size enclosures to the UK. I could ship the scale boxes anywhere in the world. Obviously, it's pretty small. I don't know if would anyone want like one of the Boom or Bust boxes. Like they're not. It's just a 3D printed miniature box. Like it doesn't even play low. It's just like it's a mid-bass box. Like would anyone want that? I don't know. I actually don't know what to do with all of these 3D printed boxes that I'm making. I've just got a drawer full of them at the moment, and it's kind of filling up. You know, I don't know what. I know you can get PLA recycled, but you got to send it off. I bet Down for Sound would bankroll the full-size finale builds. Probably. Yeah, maybe. But what's in it for him? Just a sponsor, just like a message in the video, perhaps, or something like that. Obviously, they wouldn't be able to build it for me because I'm in the UK. The problem is, if I do this, the troubleshoot, if I start off with the SPL and do the technical stuff later, no one's going to watch it. The tactical thing to do is put the juicy content towards the end of the video so people stay for the entire video. Yeah, some people are going to skip, but if you put the juicy content right at the start, then literally 80% of viewers are just going to click off and the retention is going to be horrible. So I'm writing C++ code right now for something called Audio. Man, that's fucking awesome. Love that. I would love to get into coding. I just don't have the time, man. So yeah, I respect you, man. That's you have to be pretty brain strong for coding, for sure. Right, finally got to the end of the live chat. I can power this amp up now. What changes to the scale would need to be done to make one of the small boxes actually play? Literally, for mini Bluetooth. No, it doesn't work. You can't do it. That's not how the scaling works. Okay, to get low frequencies out of a similar size enclosure to these small boxes, you can't use the same enclosure design. It's a completely different enclosure design that you would need, and the only thing that makes sense to get 30 to 60 or 80 hertz out of these small Bluetooth speakers is passive radiators. You can't use anything quarter wave because it's too big. Ends up being massive because the length of the line doesn't change as you go smaller. So you can use bass reflex, but the problem is the enclosure volumes start getting too small for the port lengths, and then you just end up with this paradox where the box needs to get bigger so the port can get longer, so the box can get bigger so the port can get longer, so that doesn't work. So the only thing that makes sense to get low frequencies out of small spaces, like small boxes like that, is passive radiators, which is why every single Bluetooth speaker company under the sun uses passive radiators. End of. There's no magical enclosure waiting to happen for getting super loud low frequencies out of Bluetooth speakers. It's been done and researched a million times. Passive radiators are pretty much the best option for that. Or some combination of passive radiators / waveguide, something, yeah. Okay. Yep, let's power this thing up then, see what she's saying. I don't have the preamp board mounted, and in the past that has actually given me a couple of headaches, so I might even go and grab the preamp card real quick, just because I've had a couple of experiences where not having the preamp card fitted does actually cause a bit of nonsense. So I'm just going to get the preamp card out of the heatsink, which is here. Just need some Allen keys to do that. Yeah, that's true. I could give them a tease. I could give them a tease of the juicy stuff at the start, perhaps. I'll have to think about it. Something to think about for season 2, maybe. What's up, Matthew? How's it going, buddy? When you're famous, there'll be collectibles. Bro, I'm never getting famous. I'm some goofy ass British guy sitting in his workshop doing audio things for geeks. That ain't fake material, bruh. I'm telling you. Okay, so yeah, you know what? This camera just doesn't go high enough these days. Back in the old workshop, I had it up really high and I could zoom right out and get the whole board in shot. But these days, it's the mounting position for it's just kind of not high enough, really. Okay, so really important thing to bear in mind with these amps is when powering them up, these amps need a load connected. From my own experience, trust me, without a load connected, they can just spontaneously go pop. So I'm going to just connect up a 16 ohm load at the terminals real quick. They don't always go pop, but there is just a small risk of it happening. And the small risk has risked itself into my workshop too many times for me to not do it now. So. Alright, cool. So, moment of truth there, I'm going to power this thing up, check if it works. I think we've got all of the feedback resistors good. Going to need our safety glasses for this one, because when these FETs go pop, they explode violently. We're going to get our oscilloscope probe, going to probe a couple of locations, going to probe the low side drain and also the rail voltage. Okay, low side drain on this side, and get my second probe here. What class amp? This is a class D, my friend. Okay, let's see what we're doing then. So power supply on, start down nice low rail voltage. Just one last check. The one thing I haven't checked for is gate resistor. I'm just going to go across each gate resistor, make sure that the gate resistors are all the correct value. So I'm going to go between output FETs. We're seeing 138. God, what, this camera drives me fucking nuts. You know what it is with this this camera that I run for the multimeter? It's because the end of the camera, the end of the wire, the USB wire, has one of these like fold over hingeable USB / micro USB attachments. So there's just like some pins pushing on the wire for the main USB, and it's just so like such a shit connection. Look at it. I'm just trying like isopropyl it up or something, I don't know. It's just such a shit, such a bullshit thing. Stupid design. Oh, fuck this. I'm gonna get the the danger toothbrush. There's the danger toothbrush. I'm also going to bend these pins out slightly as well so that they actually make a stronger contact. That should do. Right, what are we saying now then? Let's refresh my multimeter camera. Hopefully it works correctly and reliably now. Looks a bit better. Right, so we're looking for a 139 between each. Okay, oh, slight difference there, that's something interesting. Let's go back to resistance mode. Now we do have tolerance. These are gold parts. These have a 5% tolerance. So 47.1 on that one, 47.2, 46.7.8, that's within tolerance. Yeah, that's within tolerance. 46.8, 46.8, 46.7. What I don't really want to see is like 49. That would be a bit far out. 47. Yeah, I'm sure these are probably all going to be fine. Let's go between these again. Okay, this is between two FETs now, so we're doubling the resistors. 93. Oh, hang on a minute. This one's a fair bit different. What have we got here? Right, this one, see here, that's reading 50. That's a little bit high. I don't know whether that's within tolerance. Is that within tolerance? We've got 5% with the gold strip. So 47 times 0.05. This gives us 2 ohms. So it is 47. 40, it's actually out of tolerance. That one that's reading 50 is actually out of tolerance. So yeah, I'll change that one. You should use your separate power supply for testing these big amps. Yeah, man, I do. I do regularly use my bipolar supply for testing these big amps first, but the problem is, I'll only really do that if it's an amplifier that's greater than... Well, I usually only do it for either 10k amps, where, you know, they're like really, really big power, and I need to make absolutely fucking 100% sure that they're okay before I power them up. With this 5k, it's small enough that I can get away with running the power supply down at 9 volts to make the rails nice and low. Yeah, it's not such a big deal. Like if there's a fault, the FETs aren't necessarily going to die instantly like they would on the 10k. So yeah, using the amplifier's own supply is okay for these 5ks, I think. So Matthew 840, I can't really answer that because there's too many other factors that need to play into that. Like, for example, what batteries you're pairing with it. Like a 140 amp alternator is not bad. You could run a fairly big system off that, but depending on the rest of the setup will depend on A, how much power you can really run, and B, for how long. You can run as much power as you like on any alternator. The thing is that the more power you run, the quicker your batteries are going to be emptied. So yeah, you could run like 20k on a 140 amp alternator if you had a massive bank of batteries, and obviously what's going to happen is you're demoing and the alternator's not going to be able to charge the batteries back up while you're playing quick enough. So you're going to deplete the batteries, you have to sit for many hours, recharge all the batteries and continue playing. So the bigger alternator you get, firstly, the stronger you'll be able to hold 14 volts before it dips to 12, where your battery is actually supplying current. And secondly, the quicker it's going to be able to keep your batteries topped up while you're playing. it would be the resistor that's like absolutely caked in glue, wouldn't it, that I need to change. What a pain in the ass. It would be, wouldn't it? Standard procedure. Who will win? Bare Vids versus one gluey boy. I'm thinking about 6-pack of LTOs, like one bank. I would say you could probably run up to about 5k, maybe a bit more, depending on the impedance rise. The impedance rise has a lot to do with it as well, because obviously the more efficient your sub is, and the more efficient your sub setup is, then the more power, the more rated power you can run on your electrical system, because you're not going to be actually drawing the same current as if you had a less efficient system. So if you've got a nice efficient sub with a large efficient enclosure, and you're playing frequencies that do not demand high current from the setup, then you could run a big amplifier without any worries. Whereas if you're running a compact enclosure with an inefficient sub and you're asking a lot from it, then you're going to be able to, you're not going to be able to run as much power. Okay, I just need a 47 ohm in there. Now, the gate resistors that this amplifier uses are absolutely massive. There's actually no need to use a 47 ohm resistor that's that big on the gate resistor by any means. Like if you look at any of the modern amplifiers that are released, like any modern efficient amplifier, the gate resistors are all tiny surface mount, tiny surface mount resistors with very low power ratings. You don't need a great big 2-watt resistor on your gates. So yeah, I'm not going to put one. I'm going to put a, I think this is a half watt. Half watt is still overkill, but. Yo, using a car battery for bench supply for repairs is like a terrible idea. Whew. Yeah, don't do that. For a few years, I got away with just using a really basic like AC adapter. It was a 10 volt, 9 or 10 volt AC adapter, or you can use a computer power supply with no more than like 15 or 20 amps on the 12 volt rail. You don't want lots of current, that's the thing. Sure, when you're like load testing the amplifier, it's great to have current available, but not when you're just powering the amps up to test idle, to, when you're repairing them. Okay, cool. So that's that gate resistor replaced. I think all the others read absolutely fine. So yeah, we're good to go there. Hi Sam, you're going to be live for a while, possibly. I'm not planning on being live for too late this evening, but we are still early days in the stream, so. Alright then guys, moment of truth then, let's power it up and see what it's doing. I just need to probe the FETs again now, so we're going to put oscilloscope probe 1 on low side drain, oscilloscope probe 2, we're going to shove on the rail. Alright, cool, so yeah, let's go I guess. 9.5 volts. It would help if this actually was reading something. Hello. I need to buy some more scope probes, guys. All of these are forked. Right, I think that will do. Okay, there we go. Alright, moment of truth then guys. See what it does. I'm going to cover the old ears as well, just from past experience. So it's a good idea to cover the ears when you're doing this. 3, 2, 1, and let's go. Alright, cool. We have output switching. We've got 3 amps worth of idle current draw. Looks okay to me. Power off. Alright, let's check the heat on the back of the FETs. Just make sure none of the FETs are getting hot. Then that was at 9.4 volts, so nice and low. Gonna go up to 12 volts now. Do the same test again. And then once we're 12 volts okay, we're going up to 14, which is the really scary one. So 12 volts looks okay. 137 kilohertz on the switching frequency there. 105 volts RMS. Okay, 12 volts looked good. Let's go up to 14. Let's go full send, 14.6 or something like that. Let's go 14.4. 14.4 is alright. This is the bit that I hate. I hate the 14 volt test. It's such a high voltage, man. The rails in here. It's scary as fuck. Okay, ready? Nice. Yeah, that looks good. If it was going to go bang, it would have gone bang by now. Or at least during the initial test. So what we need to do now is reassemble it back into the heatsink and then do some endurance testing. Do some stress testing. But I'm happy with that. That's good. This amp should be stable up to 18 volts. The highest that my bench supply goes is 16.2. But I don't want to do that open on the bench. If I'm going to do 16 volts, I'll do it when it's in the heatsink, so that the bits of MOSFET that fly out when it goes bang can't penetrate my skin. Look, do you guys want to see? Do you guys want to see what happens when a 12K version of this goes bang at 16 volts on the workbench? It doesn't even look that dramatic in the video. because obviously in a video it's only as loud as your speakers are set. Alright, you ready for this? Media source, boom. Browse, videos. So yeah, there you go. Doesn't look good, does it? It's horrifying. I freaking hate it. Horrible. And it doesn't even look that bad on camera, like in person. In person, like it sends a shockwave through your body. The sound that it makes. Yes, we're in that video. I don't know if you could tell, right? Have a look at the camera, right? So obviously it's this view. So see me, top right of the screen. Hello. So have a look at where I was in that clip, which is this one. I was hiding. You can see that I was way off to the side, like this. I was looking away from the board. I had my eye on the scope. I was looking away from the board, and I was like this. So fortunately, it wasn't too bad. And I don't actually know why that amplifier keeps doing that. It's done that about 5 times now, and it's cost me 700 Great British pounds worth of parts. It's cost me 700 pounds of parts. I don't know why. I think the only explanation I had for it at the time was it was during the time when I couldn't get IRS 21844S chips. So I was trying IX 21844S, FAN 7535, or whatever that one is, that's the same as the IRS chip. I bought some sketchy IRS chips off of AliExpress. Like, I was just trying anything to get this amp working because there weren't parts available. And there still aren't parts available, but I did manage to buy some at some point from Farnell, because I've got some for this amplifier. So I have got 4 that I could use in that 12K that went bang. But I don't trust it. I'm just scared to do it again. I can't afford to like lose another £300 worth of FETs. Yeah, I see the Big D video. That was actually really cool. Yeah, that was a really good video. I saw him, all the amps that he's popped over time. Our seller sold me fakes for a JL6 channel. That sucks. Is that the 2092s? That Class D 6 channel? Yeah, the JL. I think I've got an 8-channel JL audio that uses the 2092s. And it was difficult getting those for some time as well, to be honest. Hi guys, the rest of the stream for the next probably half an hour is going to be bare vids and chill. I'm going to put this amplifier back in the heatsink, back in the case. So yeah, we can just do some Q&A while I do that, because the customer for this amplifier paid for an express service. I don't usually like doing that, so I never mention it. But obviously, I've got, I don't know if you can see, the amount of work that I've got to do right now. I moved into a bigger workshop. This is a bigger room than I was in before. But it has still made its way into being just the room of all of the freaking amplifiers all over the floor as well. I've just got boxes and boxes of stuff to work through. I'm sure some of you guys in the States, your workshops look a lot busier because you get more work out there in the States still. but this is pretty busy for me. This is about a 3 to 4 week turnaround, maybe longer. And that's in addition to doing Boom or Bust. Boom or Bust takes about 2 days out of my weekly schedule anyway. So I've got 2 days on Boom or Bust. I try and have at least 1 or 2 days off if I can, like a weekend kind of thing. So that's 4 days out of the week. So that gives me 3 days left to work on amplifiers. So it's about a 3-4 week turnaround, but this guy literally just wanted it back as soon as possible. I don't usually give the option of an express service, but he was adamant he wanted it back quick. So I said, look, I can do it quicker, but I have to charge you more because it's not fair on everyone else otherwise. If I'm charging you the same amount and you're getting it done in front of everyone else, it's not fair. So I'm going to have to charge you more. 30% markup on the express service, and he was happy to pay that. So I say I don't like doing it. That's because I'm a rubbish businessman. I should love the express service markup. I should love that setup because it's at the end of the day it's more money for me. But yeah, I don't like to do that. Billy says I have a 16-week turnaround currently. See, this is what it would be like if I moved to the States. People over here get annoyed. They get pissed off that I take like 3 or 4 weeks to do an amp. I guess it's expectations, isn't it? Do you still run the 1506? Matthew, yes I do. Wait, is this Matthew? Is this the Matthew that I know? Have you changed your username, Matthew? Because I don't see the other Matthew username that I know, but I see that, and oh no, you're not the Matthew that I know that comes round to my house, because you wouldn't be talking about LTOs. But no, yes, I do still have the 1506, my friend. I run it in the workshop. It is in a terrible box. I'm not getting the best out of the 1506 by any stretch of the imagination right now. It's just in a ported box that's way too... The box is kind of too big and the port's too small and it chuffs and it's port tuned too low. It doesn't sound amazing, but it does alright in here, and I'm planning a better box for it soon. Right, so yeah, let's get the heatsink, the case back for this. Bend the FETs down a bit, so we can get it back in the case. This is a full rebuild, this one. Mike Fish says, I'm an engine specialist, but electronics is my hobby. I am a electronics specialist, and engines would be my hobby if I had time. I love the idea of doing some crazy engine mods kind of vibe, but yeah, I don't have the time to learn it or play with it, unfortunately. How's it going from India? Yo, how's it going, my man? Greetings from Poland. How's it in Poland right now? I love that we have a very, very diverse audience here. I love it. What's your opinion on running mids and highs on 2 ohms versus 4 ohms? You're unlikely to hear a difference. There are definitely differences that you could measure with equipment, but given a car audio cabin environment, I don't think you would hear any difference. So basically, yeah, just run whatever. Well, you don't really get a choice most of the time, do you? Because you're either running 2 ohms because you've got too many speakers for your amplifier, so you're wiring each channel down to 2 ohms, or you're running 4 ohms because you've got single voice coil 4 ohm mids. So you don't really have a choice. Run whichever one you need to run in order to connect everything up, I guess. I'm chopping these legs off on the power supply side, but I've just looked at it. I don't actually even need to. They're not going to be long enough to hit the case anyway. But I've started now, so I might as well finish. Bevis, are you familiar with Focal PC165F? Not familiar with it by the name. Doesn't mean to say that I haven't actually worked on one before though. But I don't recognise it by its name. Mike Fish says, my turnaround is currently 5 to 6 weeks. Is that for your engine building things? That's actually quite good. For a engine building kind of like specialist guy, 5 to 6 weeks is good. My brother just waited 3 years to have his GT86 engine rebuilt. But that was due to other circumstances around the guy moved workshops in the middle of it, and there was COVID and all sorts of other stuff happened. But still, Mike Fish, I'd love to actually get your advice. I'm sure you've never worked on a Proton Cam Pro engine. The Proton's fine, there's nothing wrong with the engine. I just love to get a bit more power out of it. It's just the slowest car in the entire existence. My Proton is the slowest car on the road and one of the most gas guzzling cars on the road at the same time. It has both of the least desirable properties going for it at the same time. Great job. Hi from the Netherlands, not Holland, excuse me. Wagwan, 420, blase. Yes, please. Is it true bullet tweeters can have like white noise on low volume just because of the Class D amplifier? Yes, absolutely. Gidgerous, you're stuck. You can't get rid of it, I'm afraid. If you pair bullet tweeters with Class D amplifiers, you're gonna get white noise. The white noise is always there with Class D amplifiers. Some of it's louder, depending on the amplifier, but it's always there. Bullet tweeters are extremely sensitive and very efficient, so yeah, you're going to hear it. There's no way around it. Buy a Class AB amplifier or stop using bullet tweeters in the cabin. There's no need for bullet tweeters in your cabin. Oh my gosh. Sorry for anyone that has bullet tweeters in their cabin. I actually have bullet tweeters in my cabin as well. Oh my gosh. But no, not by choice. I'm changing them in the van. There's no need. Absolutely no need. Doesn't matter if you've got 165 dBs worth of bass. You don't need bullet tweeters in your cabin. If you want to open up your doors and play your music to a crowd at a large, long distance, by all means, load up some bullet tweeters in the doors. But if you're listening in the cabin, put some nice dome tweeters or beryllium tweeters or ribbon tweeters or varying other forms of nice tweeter on your A-pillars for optimum sound. It's the 1.6 litre mic. Yeah, it's just a terrible engine, really. I mean, I don't think it was too bad at the time. It's a budget car anyway. Back in 2005 or whenever it was released, or 2003 or whatever, it was alright. You can squeeze about 45 miles to the gallon out of it on a motorway if you're really careful on the throttle. Get around 28 to 30 round town, or if you're me, with foot flat to the floor the whole time, you get about 19. I cringed when I sent a picture of my... Sorry, buddy. I can't help it. Look, I'm a simple SQ guy. I see bullets, I cringe. Okay, it's just how it is. They're janky. They're get loud machines, and that's about it. My truck gets about 8. Oof. Yeah, I couldn't afford that if I had that. Cabin equals passenger compartment. Yeah. Cabin is where you're sitting. If you're building a system for your car so that you can listen to the music while you're driving, then that's in cabin listening. If you're building a system so that you can go to a car show, open up all the doors and the boot and everything, and then like get a big crowd and dance around your car like from a distance, then yeah, you can use bullets or use some compression drivers, or even better, air motion. I think they're called air motion transformers, AMTs. I think that's the right term. Bloody amazing things. If you've got some money kicking around, you can get some of those. They sound beautiful. Straight up kicking nuts. I'm an E. Base vehicle engine blew up the first day after finishing my war. Fuck, that sucks, man. I V8 swapped it. I love how you can just say that. You're just like, yeah, I just V8 swapped it. Like, I couldn't even know where to begin with that kind of thing. Also, the thing that really... I'd love to do an engine swap in my Proton, not gonna lie. I'd love to stick an Evo lump in there because Proton is old Mitsubishi tech, so it would go really nicely. Having an Evo engine would actually be really nice in the Proton, and lots of people in Malaysia do it actually, and Egypt. Lots and lots and lots of people put the Evo engines in their Gen 2s. But the thing that gets me slightly is none of the dials, none of the dashboard will work, will it? So I guess most people do, when you're doing an engine swap, do you like swap the dash as well, or do you just deal with having no gauges, or do you try and swap the clusters, or like how do you get around that? I wouldn't want to swap my dash just because the dashboard is very much incorporated into the audio system that I spent many thousands of pounds having built with Hard Acoustics. So I wouldn't want to swap my dashboard. I'd have to have, if I needed to change the clocks, I'd have to have some kind of custom fiberglass work done to the existing dash to mould in the clocks for whatever engine I was putting in. Why don't you just turbo it and give it a tune? Easy enough to say, but I couldn't do that myself, and I imagine that's relatively expensive. Also, just everyone that I know that's turboed their cars ends up having some other problem down the line, whether it's the turbo is the problem itself and like they end up blowing the turbos up all the time, or the added power made by the turbo ruins some other parts of the engine. Either the engine like can't take it, or they break drive shaft, or the gearbox gets fucked, or something. Like, I would love more power out of the Proton, but one of the reasons I haven't really gone down that route is just because I know that if I start throwing more power at this relatively cheaply built car in the first place, I don't really want to find out what the next weakest link down the chain is. It's just going to end up being this like forever, this never-ending upgrade path of like, break something, upgrade it, break something else, upgrade that, like. Also, with the Protons, with the Gen 2s, I am not an expert. I have no idea if this is true. I read somewhere on one of the Malaysian forums that the ECUs that the Protons use, I don't know if this is actually a thing, but I was led to believe that they're kind of like not self-healing, but they're kind of self-teaching in a way. So like you can remap the ECUs in these cars, but then over time the parameters kind of revert themselves back to what they were before, because they're like constantly like adjusting themselves based on some parameters. I don't know. I don't even know if that's a thing, but I heard that and I thought, oh well, no point getting that remapped then maybe. Next series of Boom or Bust. The next episode will be probably this week, maybe. I was meant to do one today, but I've just been so crammed in the workshop, I just haven't got around to it. Probably maybe the weekend, maybe. Yo, how's it going, Braden? Cheers, man. I only used a single super tweeter per side, even though there's two there. Nice, okay, how does it sound, my man? How does it sound? My 1.4 litre Astra gets like 22 and I bet it's slower than the Proton. I doubt it. So the Proton is slow mostly because of how heavy I've made it. I have sound deadened the absolute junk out of it. So sound deadened. The door cards weigh a freaking ton because they're T-lines made of MDF. It's got a big sub in the boot. The wiring is very heavy. It's like low. I've got like 4 runs of 70mm welding cable in there. It's heavy, guys, and it's slow to start with. I actually loved it, right? When me and my friend, when I was sound deadening the Proton, we stripped the interior completely out of it, obviously to sound deaden the whole car. And after we'd stripped it out, we had to go get some lunch. And so I drove the Proton completely stripped out inside, nothing in it at all apart from a driver's seat. My God, it picked up. It was like pleasantly nippy. I was quite surprised, and I was actually a bit gutted to then layer it with like 3 or 4 layers of sound deadening and put all the freaking interior back in. I was like, that actually felt quite nice having really lightweight car there for a minute. I guess you can't really have both. It's difficult. You can't really. There are ways to have a base car and have a fast lightweight car, but it's a bit complicated. Getting new aftermarket ECUs to do the translation, yes. Aftermarket ECUs on their own are very expensive, and then employing someone to tune it from scratch, very expensive as well. So there is that. Like, if I was going to do any mods on the Proton, it would be like relatively budget stuff. I don't have the money to throw like thousands of pounds at it at all. There's no point. It's never going to be a quick car anyway. Like, even after doing like very expensive mods to the Proton, it's going to get smoked by something out the factory from like 10 years later. You know, it's never going to be a quick car ever. And it's front wheel drive and it's heavy anyway, like I say, so there's no point really. I'd love it if there was like a relatively low cost, easy-ish way to just get a bit more poke out of it, you know? Without really risking damage to the engine in any way, or, you know, without going too crazy with it. I'd love to just get a bit more out of it, you know? So I'm going to put it back in the heatsink, but I don't trust this. This has some little holes in it. Yeah, look at that. I can't use that. I hate the yellow spongy stuff. It always rips itself kind of in half, longitudinally, like along the. It's really annoying. Ah, here we go. This looks like it might be usable. Yep, that looks like it might be usable. Let's get some isopropyl on that bad boy. Complete swap, ECU, harness, dash, harness as well. Yeah, engine swaps, yeah, I assumed that would be the case. So I wouldn't want to do that to the old Gen 2 boy, because it would ruin the audio experience that I've got going on in there at the moment, which is very enjoyable. Yeah, that's what I was worried about as well. You work on the Rockford later too. I'm working on a Rockford, but the one that we were looking at yesterday I did manage to fix. Woohoo! Man, I'm covered in this thermal paste now. Gidra says he's got bullets because the door cards were designed for bullets in the first place and replaced with something else instead of them. Like you said, AB for now. Yeah, run an AB on the tweeters or run a Mosconi. No, yeah, the Mosconi's going to be noisy as well. Yeah, your only option is to run a nice, good class AB. You only have to run it on the tweeters. You don't have to run it on the mids, unless you're getting, unless you can really hear the noise through the mids as well. But yeah, you only really need to run it on the tweets there, my friend, to get rid of the hiss. Yeah, Beast Boost, that's what I'd worry about as well. I added a turbo to a little micro and it blew up after 2 months. Later on, Mike, thanks for jumping on anyway in your lunch break. Appreciate that. That's all ECUs for the last 30 years. The tune would change the base maps or its desired parameters. Got you. Okay. I understand a bit more now. Thank you. You lost 4 miles to the gallon in your record. I probably lost a bit more than that. Weight reduction makes about as much of a difference as adding horsepower. Exactly, yeah. Yeah, exactly. Can you do a video or at least tell us what you have in your car system-wise and power-wise? You should know the van. I've done a fair few videos on the van. The Proton isn't really finished yet to the point where I want to do a video of it. Whether it will ever get finished or not, I don't know. It's kind of in that limbo stage where it's kind of a temporary install that sounds so fantastic that I'd have no motivation to like do the finishing thing on it. But maybe... That sounds like my car, that one. One moment, that sounds like my car alarm, which is strange because it never works. Nope, we're good. That wasn't mine. So yeah, the 2 Pioneers and the Proton's coming back. I have 2 Pioneers. I have 2 of the TSW 212 SPLs. The exact same, not the exact same ones, but the same ones, the same model. So I'm going to do a retro build on the Proton sometime, at some point, maybe. Hello, technical specialist. Yeah, a little bit late, but we haven't done too much today, so you're alright. The very first Bearage video I watched was the 4-inch tang band with the giant box hitting low bass. Oh, nice. Yeah, the tang band's a pretty cool thing, say. That was a cool video, long time ago. Yeah, it was Dayton's actually. Yeah, the ones I used were the Dayton's, little Dayton's. The vocals I mentioned earlier were mids and highs, not an amp. Oh, sorry. Yeah, I have no idea. I don't really have a great deal of experience with mids and highs. Just because I have never really ran that many of them. Like, I only really have experience with stuff that I've seen or used or, you know, ran or whatever. So I can only really comment on mids and highs that I have owned personally. Just kind of cleaning up the thermal pads on this sundown. Cool, cool. It should be good to go back in the case now. Slide it in. A bit of flex on there, isn't there? This is very, very heavy components on this board, so there is a bit of board flex. Alright, there it is. Back in the case. can you run Class AB amps on highs and Class D amps on mids? Of course you can, absolutely. You can run whatever you like. You could mix all kinds of different classes of amplifiers together on different speakers, depending on what is best for each individual speaker. So yeah, tweeters, I would never recommend Class D on tweeters ever, just because they're so sensitive and the frequencies that tweeters are producing are much higher, and you just need the extra detail from a Class AB, in my opinion. I would never run Class D on tweeters personally. Unless it was maybe some, the only time I'd run Class D on tweeters is if it was a properly designed, like what am I trying to say? Like a pro audio amplifier, so like a PA amplifier. PA amps are getting good. Class D technology in PA pro audio, which is where all the innovation is getting very good actually. To the point where even at full range it's very difficult. You can't really tell the difference between Class AB and Class D. One interesting question for you guys. I was actually having a chat with my friend the other day and he asked me how Class D worked, so I explained it to him. Does anyone here actually know, like actually could explain exactly how Class D works, like exactly what it's doing? Because if not, if anyone would love to know, then I will do you and explain once I finish putting the amp back together. We have a little lesson time and we'll learn exactly how Class D works, exactly what it does. Yeah, still looking for a nice two-way set around the 180 GBP for my Polo. Thinking of pairing it with an active flat sub because I want the lightweight with my 200 horses. Yeah, man. Yeah, tricky really. I don't really have any advice because I haven't done any listening to, like, you know, any door speakers that are currently on the market. I don't really have any advice for you there, my friend. Sorry. How many screws is this board mounted to prevent it from flexing? In the main board, down the centre, there is 1, 2, 3, 4, at least 4. Maybe a fifth that I have missed, but at least 4. I always compare it to going down stairs or a slide, making the steps increasingly smaller as the refresh rate goes up. Yeah, you're on the right kind of track there, Kian. Yeah, you're on the right track there, in a way. Have you heard those Class AD amps from Rockford? It's mostly just marketing fluff. Their own Class D amplifiers are very, very good. Don't get me wrong. They're extremely well designed, very clever circuitry and stuff. But at the end of the day, it is just Class D. In terms of operation, there's probably like a bunch of feedback and stuff where it cleans itself up as it's playing. You know. And some very clever ways of doing that, and some things that they've implemented to negate the drawbacks of Class D. But at the end of the day, it's actually just Class D. There's nothing like fundamentally different about how the sine wave is created. Whereas unlike Class AB versus Class D, it's very different how the sine wave is created. What happened to the sundown? Wasn't here when you fixed it. This was a full rebuild, so it needed I'm not sure what happened to it. I think probably one of the drive ICs gave up, but it needed all power supply FETs, all power supply gates, all power supply drivers. It needed all output FETs, it needed one output gate, it needed 4 output drive ICs, then, oh wait, what the heck, why did I put that in? Then it needed a single bootstrap diode, but I replaced all 4 anyway. Yeah, bootstrap diode, what else? I think that's about it. Steve R says, can understand the power supply side of the amp, but struggle to understand how the switching frequency of the output section makes a sine wave. Okay, well, if anyone else would like as well, once I've finished putting this back together, I will go over how Class D works and how it creates a sine wave from what seems like a bunch of high frequency switching noise. Do you remember the B2 Audio MA1000.4, the Class D amps with high refresh rates? They weren't very high. They were maybe up in the sort of 300 to 500 kilohertz range, but that's not very high. A high switching frequency for Class D amplifiers is over a megahertz. Those are the kinds of Class D switching frequencies you find in the really high-end Class D amps. The highest that I've ever seen, believe it or not, you're not going to believe this, the highest Class D switching frequency that I've ever seen from a car amplifier was from a Stetson. It was a Stetson EQ line. It was like a little 800 thing or 800 watt thing or something. Yeah, it was switching the FETs at like 800 kilohertz. I was like, yo! Was a bit unexpected, to say the least. I've heard that there are a few amps which can actually do Class AB and Class D on the same output stages with lower, higher power. Yes, I have heard of something similar as well. The ones that I have, no, I haven't confirmed this, I haven't like watched it do it or anything, or reverse engineered the circuit or anything like that, but there are some amplifiers that are marketed as Class GH, which I believe might do something similar to that. They might, so that they run in Class AB at lower power, and then above a certain power level, they have a MOSFET. I've seen the circuits. There's a MOSFET for each side of outputs, and I believe that above a certain power level, the MOSFET switches the rails so that instead of the transistors being fed with DC rail, it's kind of like switched, like pulsed, so that the output efficiency massively skyrockets and it's a bit closer to Class D. You're never going to get the same efficiency as Class D though, because in those Class GH amplifiers, generally they're using BJTs, which are much higher resistance and stuff. But the effect is that you can have much higher output from a Class AB amplifier with less heat because the rails are being switched. The clips that hold the FETs on, how do you get them off then back on? You use an Allen key to get them off. They make special tools for it, but I just generally use an Allen key. So yeah, Allen key to get them off, and then to get them back on, you use a hammer. So you put the clip in place, and then get like a flathead screwdriver or something to hold it onto the middle of the clip, and then just give it a few taps with the hammer, and it slots in place. AB International runs AB, then D, then H. The D runs 42 volt rails, and one stage has 92 volt rails. So hang on a minute, it goes AB, then class D, then class H. I would have said that it would do AB, H, and then D. Interesting. Like in my head, like I don't know for sure because I don't know anything about it, and today I'm just a low tier technician, but I would have thought that class D was like the highest efficiency one, so you do that last, you switch into that last. I've managed to catch up with the live chat a bit now, which is cool. I was way behind earlier. Got any other topics you want to chat about while I'm screwing this in, and then we'll go over how Class D works. Hey. What are your thoughts about the new highest SPL scores? Seems like Carlos and RP have made almost as much progress in the last year as has made in the last decade. So I don't really follow like the super like extreme builds that doing the 180s and stuff like that. I've seen a little bit. I know that someone broke a record like not that long ago or something like that, got a ridiculously high score. All I would say is that I think the biggest factor really for the kind of scores we're seeing now, power is so cheap. So two factors. Power has got really cheap, which isn't really a reason for why these records are being broken, because their cost was never a factor. But power has become readily available and more efficient, right? So that's one factor. Like running like 60,000 watts, 100,000 watts isn't actually out of the realm of the advanced bass head, whereas before it was like limited to maybe like one or two people around the world who had the ability to run that much power. Whereas these days, like there's a bunch of guys in the UK running like 40, 60k. It's accessible now. So these big extreme builds will happily run into the many hundreds of watts RMS in terms of amplifier power. Secondly, we have had relatively big improvements in battery technology in the last few years, which have sort of filtered their way down to cars and car audio with lithium. That's a big factor as well. Obviously, power starts, you know, at the storage medium in the batteries, really, for these builds. So having low internal resistance, high capacity batteries is another factor for that. And yeah, woofers have got more beefy, I guess. That was never really something that was held back as such. Like there's nothing that's been developed or invented in the last few years that has allowed speaker drivers to get, you know, more powerful and louder. It's just people have been making woofers with more powerful coils, bigger motors as time goes on, etc. So yeah, I think all the things have just come together at the right time, and we've seen a big improvement in power specifically. Yeah, I'm not too sure how Class H works either. Like I'm not a an engineer. I'm a repair technician, so I only really know what I've seen. I don't really repair a lot of Class H stuff. And even if I have repaired a Class H thing, it's just the fact that I've repaired it doesn't necessarily mean I understand how it's working at a component level. I just know where to find the problems with it and put them right, I suppose. Wow, 167 dBs at 22 Hertz. That is actually quite an achievement. That's pretty mental. Some people hate it, some people disagree, but the lower the frequency, the more difficult it is to get a higher dB figure. That's just the science of it. That's just how acoustics works. So to get a 167 at 22 is monstrous. That's a ridiculous amount of bass. Current world record is a 186.6. Carlos is planning on tickling 188 by the end of the year. Isn't 190 supposed to be like the theoretical limit or something along those lines? I'm pretty sure. I think the meter, the term level, or whatever it is, tops out at 190. So they're going to have to start making some new meters soon, hey? So Class H is Class AB with rail tracking, which I think is what I assumed it would be, which I think is where the rails are switched above a certain level, which means that the rail voltage gets sent to the transistors in pulses rather than being straight DC, which obviously greatly reduces the amount of time that the transistor is passing power. Like if you let's say that a transistor has 50 volts going to it, and it's applying that 50 volts to a sine wave, like 50 volts DC, then it is basically passing current for 100% of the time. Okay, so 100% of the part of the sine wave that transistor is generating, it is passing current for 100% of that part of the sine wave. Now let's say that you switch the supply to that transistor, that 50 volt supply, let's say that you switch it on and off, I don't know, 100,000 times a second, so 100 kilohertz. Well, and let's say that you set the duty cycle at 50% duty cycle. Well, now you're only sending 50 volts to the transistor for 50% of the time for that part of the sine wave. So you've actually cut the amount of current that that transistor is passing kind of in half, I guess. Guys, correct me if I'm wrong here, because I'm just literally talking from my brain, making it up. Like, I'm just kind of assuming that this is how it works. But this is how I would imagine it would work. Yeah, so if you're switching the rails on and off, then that transistor is actually now only it's broken the sine wave up into little chunks, 100,000 times a second. But it's so fast that you can filter it and you can turn it back into a smooth sine wave, and also your ears turn it back into a smooth sine wave as well. But there'll probably be parts of the circuit that you know, sort of connect the dots back together and filter it back into a nice smooth sine wave again. It'll be less detailed than the Class AB, but it'll be much more efficient. Okay, there we go. There is all of the screws back in the sundown. So I'm just going to check for continuity to the heatsink at any of the FETs. Really, really important thing to do. Sometimes you can get a little bit of solder that's so small you can't see it, but that's shorting through to the case. So I'm just going to probe the case and just check the back of all of the output MOSFETs specifically. They're the most important ones that you don't want shorted to the heatsink. Oof. Yep, seems to all be good there. Nice. Okay, cool, cool. Just put the back on it, and then I'll start endurance testing it while we talk about Class D. Where is the back for this? Here it is. Just going to hold it up above my head and do a little Ah de Peña Balali Bolala Sundown Navaized. Get all that crumbs out. How do you do your endurance tests on the bench? Well, so I have a couple of different endurance tests depending on how quickly the customer wants the amp back. So endurance test number 1, which is basic level endurance test, essentially with the way that car amplifiers work, the way that Class D works, okay, is that it's not actually critical to run the amplifier on a heavy load to confirm its reliability after repair. If the amplifier has a fault or a developing fault that's as a result of the original failure or the repair, then it will present itself as quickly with the amplifier running idle as it would with the amplifier under load. So for the most part, you can get away with, if you're wanting to check the amplifier's health status and confirm its reliability after repair, if you just run the amplifier on a low output, low volume for 3 to 4 hours, then you're pretty good to go. There are a tiny amount of faults that could exist that would only present themselves under a heavy load. One of those kind of issues could be if you have used mismatched output MOSFETs in the amplifier that have different RDS ratings, and if only a small handful of those MOSFETs are actually passing the power because they are lower resistance than the rest of them, then you'll get power imbalance on the output section, and those lower resistance MOSFETs might fail because they're doing most of the power. That's one issue you can have. Another issue you can have with the amplifier only presenting a problem while it's under load is fatigued traces that carry power, or very rare drive circuit faults where it oscillates okay at idle, but when the rail voltages droop down and there's some sag across the board, then an issue presents itself. But it's so rare that I've only ever seen it twice. 2 times in all the years I've been repairing amplifiers and the thousands of amplifiers I've repaired. I've only ever seen it happen twice, where an amplifier would idle absolutely fine but present a problem under load. So stage number 1 for endurance test is literally just let the amp run for an extended period of time, get the temperatures in the heatsink up. So I just use my 200 watt bench power supply here with a 16 ohm resistive load on the outputs and just run it for 3 or 4 hours. Literally, it's going to be fine. However, if there's a specific requirement to do a heavier test, like the customer wants a dyno test done, for example, I do have some server power supplies that I can run. I can dyno up to about 4,000 to 5,000 watts RMS here in the workshop. So I can do a dyno run, or I could leave the amplifier running, sinking more power into the dummy loads for an extended period. But I have to charge more for that because it uses a lot of electricity to do that. The stage 3 endurance test is I actually mount the amplifier in my van. I use the amplifier myself in the van on the DDZ4s and slam it for a few weeks, make sure it's all good. That's the stage 3 endurance test. Okay, so we're going to endurance test this amplifier a little bit, just have it running idle while I explain Class D for you, if you like. Then I'm going to go get a quick drink. Gonna have like a little 5-minute break, and then I might carry on, or might lock off the stream depending on how I'm feeling. So let me just get this wired in. I do have the LTT screwdriver, that's correct. It was sent to me as a gift by a very generous follower. So if you're watching, thank you very much. You know that's massively appreciated. The only thing about it is I was sent the black version, which is great, it's awesome, it's cool, but I wouldn't have got the black version because when you're using a screwdriver, when you're actually using a screwdriver for its intended purpose every day, the black version is going to get ruined, it's going to get scratched to pieces, which is why Linus didn't even want to produce a black one. He said, no, we're not doing a black one. And the community pushed and pushed and pushed, and they did a black one as a special edition run. So the silver one obviously would look brand new still, but because I got the black one, obviously the tips, they're not black anymore, and I've got scratches all up the shaft here, so here's what it is. But yeah, no, I really appreciate the guy who sent one of these over. It's really cool. Oh, I didn't go to the loft to get the capacitor value yet. Who was it that was asking for a capacitor value on an MTX? Are you still here in the live chat? If so, make yourself known and I'll go and get the MTX down for you right now, because I promised to do that. I had forgotten. Roderick. Okay, awesome. Right, let's go grab it. I'm just going to set the sundown up so that it's actually powered up and oscillating, so that we can leave it on, running, while we do some bits and bobs. Okay, got the thing in there. Got to just grab a signal real quick as well. Let's go in. So I'm going to start it off running on 10 volts for the first sort of like 10 minutes or so, just so that if there is an issue that presents itself early on, the rail voltage isn't too high. It should prevent any explosive damage from being too bad. So I get my tweezers to short out the remote and positive terminal as well. Yep, there we go. So let's power it up and let's give it sort of 50 Hertz, something like that. Okay, there we go. So how much current are we going to draw from this amp for the time being? Let's go for about 6 amps. So let's get a nice clean sine wave on there. Let's go remote and 12 volts. Shove the tweezers in there. There we go. So amps on and running. So I'm just going to go up in the loft right now and grab the MTX for my guy here. Where are we? BRB in loft. So yeah, back in a sec. Okay, my guy. Which capacitor was it that you were looking for information on, buddy? I can't remember what you said it was. C177. It's over by the transformers. Okay, let's have a look. So it should be over this side. C177. Is it a ceramic capacitor or is it a big chunky boy? We've got C171, C181. 157. Ah, here we go. 177. Yeah. So basically, buddy, provided that you've got C122 and C149, you can figure out 177 because they'll be the same value. Yeah. So C122, C149, and C177 will all be the same value. So just for future reference, you don't need to go wandering and looking for schematic for that, because not only do you have the same capacitors around it that are going to be doing the same thing, you've also got another one of those circuits for the other transformer. So for example, C178 will be the same value as well. Thanks Stephen for the 5, really appreciate that, buddy. That's really kind of you. So yeah, provided you have, do you have a tester? Do you have one of these? Can you read the capacitance of one of those? Because if not, I'll desolder one of them here and I'll get the value for you. Yes you do. Okay, fantastic. That's good stuff. Alright, cool. I can put this back in the loft then. Okay guys, let's go over how Class D works, shall we? .5 amps on the amplifier here. Good stuff. Okay. Here we go. I'm just finding a picture that can explain it in nice, easy terms. Okay. So, guys, are you ready to learn about how Class D works? NUEN says, what does he say? He or she say? I'm saying this because I wanted to test this in Boom or Bust, but Sam, just allow one sub by the time. I'm not sure what you mean. Quick segue, yeah, don't see any other comment from you, buddy. Okay, so guys, Class D, if you're interested, let's have a look. How many viewers we got? 50 at the moment by the looks of it. It's not that great. So, you feed your amplifier with a sine wave, okay? Here's your sine wave, this little blue guy right here. So you're feeding your amplifier with your blue sine wave. What the Class D amplifier does, once it's been through the preamplifier circuit, let's just make sure that I'm in the view. Oops, opened Audacity by accident. Once your sine wave has been through the preamplifier circuit, it gets overlaid onto a triangle wave like this. Okay, so your sine wave is compared to a triangle wave. So the triangle wave, as you can see, is a much higher frequency than the sine wave. So what happens is the sine wave and the triangle wave are compared, and a set of pulses are created in reference to what the sine wave is doing at each time that it crosses a peak in the triangle wave. So you can see here that the sine wave is crossing the triangle wave like this, and every time it does, there's a pulse created down here. Now the width of the pulse is determined by the width of, or basically how much sine wave was in this gap. So you can see here that when the sine wave was sort of more towards the middle, you have a wider pulse. Then on the next sample, we have much less of the sine wave in the top of the triangle wave, so you get a smaller pulse. And the smallest pulse is right at the top of the sine wave here. We get a tiny little pulse like that. And then as we come back down, for example here, we have quite a lot of the sine wave in the middle. It's in the middle as well. It's in the middle of the triangle wave here. So you get a 50% sort of roughly duty cycle pulse here. And as the sine wave goes even lower, it gets picked up by these spikes of the triangle wave. Therefore you get these little pulses, or if you're looking at it the other way around, if you're looking at this spike here, let's grab this with a slightly different colour. If you're looking at the spike being like this, then you've got a lot of the sine wave here in the bottom of the spike. Therefore you get a big pulse. But you can also look at it upside down and say, oh well, the spike is actually this part here, and you've got a little bit of the sine wave in the top of the spike there, therefore you get a little pulse here. So basically, whichever way round you look at it, you're getting a representation. This here is creating a representation of the sine wave in binary almost. It's almost like in binary, in pulses. Okay, so that's what the amplifier does first. It converts the sine wave into pulses by overlaying a triangle wave and comparing where the sine wave is on the triangle wave at any time. So obviously different Class D amplifiers will have different Class D switching frequencies. So if you're looking at this sine wave here, the amplifier is taking a sample of the sine wave here, and then it's taking another sample here, another sample here, another sample here. So it's taking samples of the sine wave, and then afterwards, a bit later on, these samples, they all get connected back up together again. The problem is that if your Class D switching frequency isn't fast enough for the audio that you're playing, okay, let's just erase part of the sine wave here. Okay, let's say that the sine wave that you're listening to has some high frequency treble on it, okay, and let's say, get the right colour here, let's say that the original sine wave actually does this. It's a little bit shit. Let's do that again. Let's say that the original sine wave actually does that. Okay. Well, then the problem is that because you're sampling here and here, you're actually missing this information entirely. This little thing doesn't get picked up at all by the pulses that are generated from those two spikes. So the detail is quite low. Now, obviously, the faster the faster the triangle wave, the more samples it takes along the sine wave. So that's why for full range you need a faster class D switching frequency to pick up more detail in the sine wave that you're feeding it. So that's to bear in mind. So once we've got our pulses, okay, the amplifier has generated its pulses here from the sine wave. Now, in order to drive MOSFETs, some MOSFETs, this has to be split into high side and low side. So basically, the amplifier is going to be supplied with two rail voltages, positive rail voltage and negative rail voltage. And we need high side and low side drive for the output MOSFETs, for the N side and the, well, what would otherwise be the P side, but it's bootstrapped. Anyway, I won't get too much into that. So once the amplifier has split these pulses into sets of pulses for the high side and sets of pulses for the low side, they get sent to the MOSFETs. And if you have a look on the MOSFETs, you'll notice that there is basically this waveform, but at a very high voltage, of course. So if you probe the low side drain, you get this waveform at a very, very high voltage. So this is what is connected to the speaker terminals. However, in line, in series with this, which is what's on the MOSFETs, which is what's at the speaker terminals, you have a great big inductor. Okay, so this is what's sitting on the speaker terminals of the amplifier, but you've got a great big inductor in the way. So an inductor is a natural low pass filter. The reason that an inductor is a low pass filter is because an inductor has kind of what I would call electrical inertia. So if you try and, so imagine an inductor as a very heavy mass. If you try, let's say that you've got a big heavy circular weight in your hand, like from a dumbbells, right? You're holding it up like this. Let's say that you try and spin or rock the weight very, very quickly like this. Because the weight has inertia, it's very difficult for you to actually oscillate that disc at a very fast speed. So if I grab this little piece of cardboard here, I can do that very, very easily, and it's fine because this doesn't have much inertia. Whereas if that weighed 50 kilograms, I'd only really be able to do it very slowly because of the inertia that the weight has. An inductor works in the same way. It has inertia, so therefore if you try to pass AC through it at a very high frequency, it just kind of, it doesn't pass, it just kind of gets stuck and goes backwards and forwards on itself and doesn't pass through the inductor. Whereas lower frequencies do, and DC does. Like if I was just to try and emulate DC, that's DC. Obviously I can do that with any weight. So because we have an inductor connected to this high frequency, we actually completely negate all of the high frequency information that this wave is carrying. So we get rid of it. However, what's left is the potential differences as a result of the pulses. So let's have a look. Let's say that we have up here, wait, what happened to my toolbar? Here we go. Let's say that we have 50 volts up here, 0 volts in the middle rail, and negative 50. So let's have a look at this first pulse. Okay, so this first pulse right here, it's about 50% duty cycle-ish. So this set of pulses here, we're going to look at two pulses together. We have, I would say, about 40% of this pulse is up here at 50 volts, and about 60% of this pulse is down here at -50. So what happens if you take so we've got 50 volts, so we've got the potential difference here is 100 volts, so we've got 100 volts. So let's say we take 40% of 100. Hang on a minute. Yeah, so how am I trying to explain this? So you've got the pulse staying on longer on the -50 side than it is staying on the +50 side. So therefore, the average voltage of this pulse here, this set of pulses, this up and down, the average voltage of it is going to be about here. So if you think of this like a kind of filler meter thing, right? This is like a VU meter. So with this amount of pulse being down here, we've got 60% of the pulse being negative. Therefore, the resulting voltage is going to be about here. So that's at maybe, I don't know, minus 15 volts. Okay? Let's have a look at the next set of pulses along. We have this right here. So we have, I've kind of overlapped a little bit with my drawing, unfortunately, so it's quite hard to see. But we have a very tiny amount of energy up here at 50 volts. But we have a huge amount of energy down here at -50 volts. So therefore, the averaged amount of voltage from this set of pulses is going to be much closer to -50. Now for this set of pulses, for this one and this one, the average is going to be down here. For this set of pulses, again, it's down here. For this set of pulses, it's back up at about -15 again, possibly somewhere around about that. And then for this set of pulses here, they're about even. You see how we've got almost even amount of time spent up at 50 volts and amount of time spent down here at -50. It's a little bit more on the positive side. So therefore, the average voltage across this pulse is going to be about here. If we move on to the next set of pulses, we've got these two here. We've got, like I say again, we're going more into the positive now. So we're now going more into the positive because we've got longer pulses at the top here. And then we end up with less amount of time back down to 50-50. So when the pulse is 50% up and 50% down, when you've got the same amount of time spent at 50 volts and the same amount of time spent at -50 volts, you end up with basically no potential difference, nothing. They cancel each other out. Whereas when you've got a difference here, like you've got more time spent down at -50 versus up at +50, you end up with a potential difference of like -20, 15 volts. So that is how you end up with an averaged out amount of voltage across these pulses. So basically we have both of these things together connected to the speaker terminal. You have the high frequency pulses and the resulting averaged voltage as a result of each pulse. Now the only thing that makes it through our inductor here, because our inductor is a natural low pass filter, is the resulting averaged voltage from our pulses. All of the high frequency noise gets completely lost, so we're only left with the sine wave coming out of the speaker terminal of the amplifier. So that is a very basic rudimentary explanation of how Class D works. Yo, thank you very much Stephen for the 5, really appreciate that, buddy, that's really kind of you. And thanks to Roderick for the 10, thank you very much, buddy, appreciate your support there. I'm just turning the voltage up a little bit on the sundown, going to go up to 12 volts now. Make sure the sine wave still looks pretty, yep, looks good. Yes, Frank is absolutely correct. There is also a capacitor. The capacitor is very important. I didn't include it because I'm not including every part of the circuit, but essentially, in order for the inductor to work, there must be a capacitor to ground. So the inductor has to be loaded. Okay, so let's do that there. So this is our inductor. This inductor isn't actually going to do anything unless it has some way to ground out this high frequency noise. So the high frequency noise is only going to be blocked off by the inductor, provided the high frequency noise sees a pathway to ground through the inductor. Okay, so in order to do that, you would think, okay, cool, so all we do is we add a ground to the inductor here. And that gives the high frequency noise a pathway to ground. But have you noticed the problem here? That also gives the low frequency sine wave a pathway to ground as well. Well, that's no good. That means we're going to be basically sending both the sine wave and the high frequency to ground, but it's going to draw a load of current because the sine wave isn't being filtered by the inductor. So how do we get around that? Simple, we just add a high pass filter capacitor in line with our pathway to ground. That means that, oh, that's a really crappy capacitor drawing, but that means that the high frequency noise sees a pathway to ground through the inductor, through the capacitor, because the capacitor can pass the high frequency noise. Whereas the low frequency sine wave doesn't see the pathway to ground here at all, because it's a capacitor, therefore it gets blocked, and therefore it takes the pathway to the positive terminal over here. So that's how the filter network is sort of set up in the Class D. See you later, Enui. Appreciate you being here. So what's the frequency of the triangle wave, says Steve R. Well, it changes, it depends. Some amplifiers have a slower triangle wave frequency and thus therefore switching frequency. Some amplifiers have a faster Class D switching frequency. Subwoofer amplifiers tend to have a Class D switching frequency of between 70 to about 200 kilohertz. So 70 to 200 is the standard average for a subwoofer amplifier that I generally see. A car audio subwoofer amplifier generally between 70 and 200. For a full range car audio Class D amplifier, they generally seem to be between 200 and 500. Some of the best car audio Class Ds I've seen are up at 800, and the best Class D amplifiers in like home audio and pro audio application will be over 1 megahertz, which is 1 million samples per second. So yeah, that's how Class D is doing its thing. What's up, Durr? How's it going, Durr Samon? Okay, so we've got this Sundown audio here doing some endurance testing. I've got a Rockford amplifier to work on. Another Rockford, believe it or not. And this thing wants some new output FETs and some new, it needs a replacement drain emitter resistor. Yeah, you can use BD139 and 140 for the power supply buffers. I use BD676, I think it is, for the PNP side, just because they're a bit beefier. They'll take a bit more abuse. So I've got, this is one of the last Rockfords that I've got here to fix, apart from the processors, of course. This just needs some 540s in the output and some 9540s and an emitter resistor, and then we'll be able to test it and see whether it's any good. This is, I can't remember what model this is actually. This doesn't have, does it have the model printed on it? I can't remember. Yeah, I can't remember exactly which model this one is. Okay, seems I don't have enough IRF 9540s to load this up. I don't think this one takes just 540s. I can check that by looking at the rails. Pretty sure this one takes this one. So I need to order some new parts for this one actually before I can work on that, unfortunately. Guys, so a little bit of a treat then. We could do something a little bit different this evening. Your choice. Would anyone like to see Boom or Bust, the sealed, so I've got this little sealed box here. This was from the Fibonacci 4th. I intended to put this into the Boom or Bust chamber to see how a sealed box did. So I was going to make that into a separate episode, but I don't know if I will. Maybe I could just do it here on live. So does anyone want to see what kind of dBs a sealed box does in the Boom or Bust chamber? Or would you rather see some more amplifier repair? Let me know. I can either do the sealed box in Boom or Bust, or I can do some more amp repairs. I think if I do some more repairs, we'll probably look at the Rockford Fosgate EPX2s, the processors, if you're interested in that. I won't be able to do both, I probably won't have time. I don't know what you mean, Tech Tom. Did you happen to use the probe from the oscilloscope to close the circuit? I'm not sure what you mean. Actually repaired an ARC audio and now watching the Bevis. Nice one, Dad. Good job, buddy. Appreciate that. Nice work. Okay, you want to see amp repairs? No worries, we'll do Boom or Bust another time. Okay, so what can I work on? Yes, I should probably look at these EPX processors. Okay, so this was one of the EPX processors. The one that I should work on is the one that I removed the power supply FETs on, which was, what was that? Here we go. So this is one of the Rockford Fosgate processors that we were working on a couple of streams ago. I actually ordered some new power supply transistors, some originals. These are some BD911s. This is what this this processor used in the power supply from factory. I'm just going to crank the sundown up to sort of 13 volts here. It seems to be pretty stable. I would say this is probably good to go. Hiya Charles, how's it going? Yeah, I'm gonna unplug the sundown just because I want to get the power supply wires plugged into this Rockford processor. So that sundown's done alright. It's done however long, little bit of testing so far. I would say that's probably good to go, but I will do a bit more testing on it before it gets sent out. I'll run it at 14 volts for a bit longer and stuff. Are you using some kind of isolation transformer? Nope, I'm not. Hey. Okay. So, I don't know if you remember from a couple of streams ago, but we were looking at this Rockford Fosgate EPX processor. This one had a dead power supply. It uses BJTs in the power supply, which is very uncommon. I guess it was back in the 90s and they didn't need to use FETs because it was a processor and didn't, you know, whatever. But anyway, so yeah, to get this up and running, it's self-oscillating. This power supply is self-oscillating. It doesn't have a TL494 or any oscillator, any discrete oscillator. I guess it's using some kind of feedback from the transistors being connected to a transformer in some way. I don't know. This is different to anything I've looked at before. So we tried mounting some random BJTs that I had laying around. Some 139s didn't work. So I ordered some of the original transistors that this amplifier uses, just in case it is fussy with this type of transistor it needs to set up oscillation on the power supply. So we're going to fit those first and see if we can get the power supply oscillating on this processor. What's up, Mike Honda? How's it going, buddy? I'm going to put a little bit of thermal paste in here, just because it will do a better job of dissipating heat rather than just being dry on the metal there. Okay, so let's have a look at this processor. So this is the power supply section. Okay, these are the power supply transistors. There's no power supply FETs, they're BJTs. A couple of BD911s. Now there's no TL494, there's no discrete oscillator or anything on here. Looks like that the power supply switching is set up by just the fact that the transistors are here. There's a transformer, you've got a diode here, probably a capacitor somewhere as well. I don't know. Who knows? I'm not sure how this power supply works. So we're going to plug some power wires back in and see if we can get to the bottom of whether this is oscillating or not. Ground is working. Okay. Damn it, my wires are too thick to go in here. This is super annoying. Maybe I'll just... 1 second, guys. My wires are too thick for this boot. Plug some smaller wires in. So this might just magically work now because we fitted the original replacement transistors in place, but it also might not. So let's have a look, see if we get any oscillation on these power supply transistors. Oh wait, yeah, there we go, we do. Awesome. So I guess it just needed, it's very fussy, it needs specific transistors in order for that to work. Oh, that's great. Oh man, I thought we were going to be diagnosing some crazy issue. Alright, excellent. So, this unit wasn't powering up before, so we haven't actually checked any of the other parts of the circuit to see whether it's making audio or anything like that. So I'm going to connect it to the main panel now and just check that it works and produces audio, and if not, we'll diagnose that. So I'm not going to mount the graphics, what do you call it? I'm not going to mount the EQ card just yet. because I just want to see what the circuit does without the EQ card mounted. I just want to see where there are some sine waves and where there are not some sine waves, just so I can understand about the other ones a little bit better. So let's plug our RCA in. Here it is. We're going to go into A side here, down here, A red. And we've got 45 Hertz, go up to a little bit of high frequency, 447 Hertz, that will do. And scope, zoom out. Cool. Okay. So let's try and follow our audio wave through here. Power up. Drawing an amp. And preamp source A, yep, that's all correct. It's probably all set from before, so if I have a look in here, let's look for our sine wave. Okay, there's our sine wave. So we shouldn't have any DC on any of these preamplifier op amps. We should just have our sine wave. Excellent. So then it goes into this digital potentiometer here. This Dallas unit. I think it's pin 3 it goes into. Aha! And it comes out. So it goes into pin 3, comes out of pin 4. Awesome. Okay, now this is interesting because on the unit that we looked at the other day we didn't actually have that. We had audio wave going in pin 3 but we didn't have anything coming out of pin 4. So that's really great to see. And that sine wave amplitude is actually changing as I increase and decrease the level on this unit. Yeah, it's working perfectly. Awesome, okay. Love that. So that is how that should operate. I'm glad that I've seen that because I wanted confirmation that that's how that should work. Okay, let's check the other one. So we have the other side input. Let's just check. Let's see. This is going to be up the top here, probably. Yep. Yeah. So we have output again from the top of this digital potentiometer. Awesome. Okay. So now the question is, do we have any RCA output from the actual rest of the processor? Possibly not. The reason, oh, that's got DC on it, that's not good. Got 7 volts on the RCA out over here, that's never a good sign. Got -3 volts on this one, bloody hell. +5, it's all over the place. Now, that might be because we don't have the EQ card fitted. As I've experienced with other Rockford devices earlier today and yesterday, sometimes when stuff isn't connected and op amps are left with their inputs floating, they can give you DC on the output. So let's grab one of the EQ cards. Here we go, here's one of the EQ cards. And get that mounted and see whether we get any audio output. Now, you're not supposed to need these for there to be audio output. However, I think there's some jumpers that need to be moved around in order to give you audio output when this isn't fitted, and vice versa. And I don't know what those jumpers are or where they are. So there's a couple on the board here that are labelled. Got this one here which can be moved. BL BL BP in. I don't really know what that is. I could look up the manual, I suppose. Front left all pass, front left band pass. BR band pass 2, be left bandpass 2. So yeah, that's just some jumpers to change or to remove or whatever parts of this. Anyway, I don't really know if there's any jumpers for sending the audio up here. Possibly. It could be what these are for here. We might have to remove all these jumpers in order to use the EQ card. I'm not entirely sure. Theodora says, dude, I like your videos. Either Amplifier, boom or bust. I kind of miss those videos where you used to explain stuff. Oh, fair play. Well, what kind of stuff would you mean explaining? Thanks. Hello from Denmark. How's it going, buddy? Hope it's good in Denmark. So let's get this EQ card. Fitted and see whether we get any audio output now. Well, 1.3 amps worth of current draw. Got 6 volts, 7 volts DC on this RCA output. So yeah, something is not happy, is it? Got negative 3 volts on this RCA output. Positive 5 on this one. That one's alright, but we've got no audio output still. All of the processors seem to have this same issue, that there's no audio output. I wonder if ChatGPT knows anything about these, because these are old enough that they'll be in his kind of range. Okay, I'm going to ask it with the Rockford EPX2 when not using the additional EQ board, are there any jumpers which need to be set on the main board to allow audio output? See what he says. No, he doesn't know. So unless anyone else knows, because I could try following the audio through the board here, but without knowing whether there's supposed to be audio in one place or not, it's very difficult to tell whether we've got a fault or not. So we've got audio coming in and coming out of the digital potentiometer here. That then goes to TP2. So TP2, where does that then go to? goes, that seems to go into the processor here. Okay, so I assume we should then have some kind of audio out of the processor. Looks like there's some junk actually kind of caught up in the pins of the processor here. Let's try and clear that out. What is that? Some kind of cobwebs or something? Not entirely sure. Yeah, I think that's some spider webs in there. These processor units were all super janky. They were all like stored in a loft or shed or something, and like spiders had just like got to them. Right, so if the audio goes into the processor here from the digital potentiometer, then it needs to also come out before going to the other digital potentiometers over here and final op amps. So, okay, let's see. Audio going in. Audio coming out, but it's biased by about negative 0.6 volts. I wonder if that's how that's supposed to be or not. Almost every single pin on this this processor is like biased into the negative voltage range. So look at this. I don't know if this is correct. It doesn't seem right. So maybe we're missing a supply voltage. Let's have a look. Let's have a look at our supplies over here. So we need plus minus 5. So we've got plus 15, ground, plus 16. Okay, that's 15 volt reg. Negative 14, ground. Yeah, that's correct. So then over here we've got plus 5 and minus 5. Yeah, so we've got all of our supply voltages. So let's have a look at what voltages we've got going into this main IC. So we've got plus 5. Excellent. Audio. And then we've got audio reference to a little bit of negative voltage there. We've got negative 0.2, negative 0.1, negative 0.3, negative 0.3, negative 1.4, negative 1.4, negative 4, negative 1.4. So like everything is kind of biased like into the negative voltage by a random amount. And things like that usually tend to mean that the chip is leaking or dead or something like that, or there's some kind of voltage leaking where it shouldn't be. So I'm going to turn my attention to the pin that has the audio coming out of it, which is actually biased a little bit down into the negative by about 0.6 volts. So let's see where that goes. Let's find it on the bottom of the board here. Okay, that goes there. So we've got a trace that comes over, and yeah, it goes into the EQ board. See this? So we do need the EQ board there by the looks of it, because there isn't like another trace that leads off from that and goes anywhere else. So yeah, it looks like we do definitely need the EQ board here. If we don't have the EQ board here, then we can probably just bridge over. Let's have a look. We've got some markings on these headers. Maybe if I just bypass the EQ board real quick, just by bridging over some connectors. So left in lol 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 LRL LOR plus 15 plus 5 minus 5. So I assume that this is all going to be inputs. LOL. And then the other ones down here, we've got digital ground, some data stuff, SKSD, some data stuff down there. this one over here, we've got some more data stuff. So I assume that these ones are ins and outs. So the input I've got is up here. The input I've got is LOR. So if I change my RCA to the other one, I should have LRR. No. I've got LOL. Okay, so the LO seems to come from the chip, and the R seems to come out of the preamp card, I assume. Let's just plug into input B as well, just to double check. See what that's doing. Preamp source Rob. There we go. Okay, yeah. That's correct. Okay. Cool. So that's working as intended. So what I need to do is I need to jump over from I need to jump over these two and these two here to allow signal to pass back into the main board. So I'm just going to borrow some jumpers from another one of these real quick in order to do that, just to speed things up a little bit. So there's some jumpers over here. I'm just going to take them from the RC outputs over here. Remind me that I've done that. So let's just shove those on there for a minute. Okay. So now that we've done that, let's see what we get on the RCA outputs now. Well, let's just see what we get in these digital potentiometers. Steve, can you tell me how to pronounce that? Can you give me a phonetic spelling, because I don't want to say it incorrectly. Okay, so now we're passing audio through. Let's see whether it ends up at any of these digital potentiometers. Doesn't seem like it. However, we have a bunch of DC on a lot of these digital potentiometers, the wiper and the track actually, which is kind of strange. We shouldn't have any DC. Like, here we go. See this op amp here, this is a 072. We have DC on pin 1 and 2. I don't know whether that DC is coming from this digital potentiometer or whether it's coming from the op amp. You know what? All of these op amps seem to have like negative voltage or all kinds of voltage leaking on their where they shouldn't have. So I'm tempted in this instance to literally just pull every single TL072 here and see if there's any DC on the digital potentiometers. But the interesting thing is I'm not seeing any audio input to the digital potentiometers either. So we're jumping over from these headers, but I'm not seeing where that really goes. Seems to go into these capacitors here on the board at the top. So the audio seems to maybe go into these large capacitors possibly here, which will do DC blocking or supposed to anyway, but it doesn't seem to be doing DC blocking. Then we go into there, and then where do we go? Do we go into the processor again, maybe? Let's have a look. Let's see whether we've got any other processor stuff going on. So we've got the output there. We've got 1, 2. So input, output. Maybe that routes it back into there. It does. So it routes the audio back into the processor here, by the looks of it. So then we've got another output there. We've got a bunch of outputs. Here we go. Looks like we've got a bunch of outputs for each of the different filtered frequencies. Yes, we do. Okay, fantastic. This is great news. This means that the processor itself is working. You can see here how we've got an output there which is clearly a high pass output. You see there, as the low frequency comes, the amplitude gets lower, and amplitude gets higher as we go up in frequency. This is great news. So that's cool. We've got an output there, an output there, an output there. Right, okay. So where are the outputs from the processor going to then? I assume that they'll just be literally going over here somewhere. Yeah, there we go. So now it appears to be going over to, well, at least one of these jumpers. We've got BRP over here. So I assume that should go to this digital potentiometer. Yeah, not really seeing any audio. Oh wait, hang on a minute. Is that a... No, I thought this was a burn mark on this 072C, but I don't think it is. I was like, wait a minute. Okay, so I need to do some tracing with my multimeter to figure out where the audio goes after it's come out of this processor, because we've got good audio coming out of the processor here, pretty much on all of the low pass and high pass channels. Just can't seem to see where it goes next. So I'll do some tracing with my multimeter and see if we can figure out what it has continuity to. I don't know if the op amps here, these 072Cs, are before or after the digital potentiometers here. I think they're before it actually. The reason I say that I think they might be before it is because we have DC on what looks like one of the input pins to this digital potentiometer. Maybe? Oh, you know what, actually someone sent me the schematics for this. I forgot last time someone sent me a schematic, so let's bring up the schematic and actually see where it goes. Steve R. How do you say your daughter's name, buddy, Steve? I want to give her a shout out, but I don't know how to pronounce it, so can you give me a phonetic spelling? Actually, you know what? I think Steve might actually be very far behind in the live, because I just noticed he said 99.98, so $100 is good. I think that was like way early on. I think the pronunciation might be, wait, Niam. No, I don't know how to pronounce that. Sam, with everything you made for Boom or Bust, are you already looking to make upgrades to your 3D printer or get another one? Yeah, I'd love to make some upgrades to the Ender 5. I like the Ender 5, I know it, and I know that you can really turn the Ender 5 into a proper beast with mods. It's a very common boy printer, therefore there's lots of mods for it. So I'll probably stick with the 5. One thing that I want to do is I want to upgrade the hot end, and I want to have a direct feed extruder. Direct feed extruder, upgrade the hot end, upgrade the cooling as well, get better fan ducts for nozzle cooling. What else do I want to do to it? Can't think of anything else right now. Frank has sent me a PDF. Oh, sweet. You have a schematic for this. That's cool. I'll check my PMs. Is that in Facebook, buddy? Yes, Facebook. Alright, I'll check it. Analogs Nexus says, 2 weeks ago my 13-year-old Alpine amplifier died. Protect light is on. Yeah, you need to go ahead and pull the back off and see what died. Check the output transistors and MOSFETs, check for vibration damage, check for moisture ingress, condensation, everything like that. Oh, you have to change something in the menu when the card isn't present. Okay. Right, let's bring up the details. Alright, we're looking at page 38 and following. Let's have a look. Alright, installing the optional thing. So this is installing the card. Remove the top half of the 2 standoffs. Remove 2 jumpers corresponding to LOL. Okay, adapt E14 software by selecting D card from the menu setup. From the setup menu and select E14. Alright, well we need to go ahead and probably cancel that then. So let's have a look. Just to check whether that's actually selected in here. So it's power up. So you're going to go to setup. D card. E28 is currently in here, oh, I can deselect that, there we go. Initializing. Alright. Alright, let's see what happens now. Okay, so that looks the same out of the chip. Doesn't look like we're getting any difference. We've still got no output on any of these RCAs over here. Still got DC. I suspect that the op amps might be dead. You know what I think might have happened? I think that all of these process units might have been connected to a faulty amplifier at one point in their life, and it's killed like some of the final stage op amps by the RCAs, because there should never be DC on the RCA output. So I think that's probably a fault. But I just want to see some audio going into these digital potentiometers here. Oh wait a minute. Looks like we might have something there. Aha! What do I see there? Cheeky little bit of audio. Okay. It's not very high amplitude. See if I can get it a bit more. Let's go to the setup here and let's just increase the volume right up to the max. Manual A. Okay, we're clipped now. Ooh, a nice clipped sine wave there. Love to see it. Well, there is a little sine wave there. And we have a very noisy sine wave coming out. There's barely any amplitude though. And then we have a sine wave on this op amp. And we have a very noisy sine wave, very low amplitude on the outputs of this RCA. So okay, something's up here. Something's up here. So we've got a tiny bit of output now. The first bit of output I've ever seen, but it's extremely tiny. Very small amount of output. Yeah, we have a sine wave going into what looks like most of these digital potentiometers now. Yep, we have a sine wave going into each of these digital pots. Awesome, love to see it. So that's working. Seems that we only have a sine wave going into one side though. If I plug the RCA into the other channel, I'm not actually seeing any sine wave on any of these for the other channel. Yeah, so it only seems to be the white RCA input that's actually getting audio signal over here. And that's coming out this side of the chip. So the white RCA, we have audio output coming out of this side of the chip. Okay. And with the white RCA, sorry, with the red RCA, we have audio coming out of this side of the chip. So when it comes out this side of the chip, it doesn't seem to make its way to any of the digital potentiometers over here. So we might have a bad capacitor, something like that, that's blocking it. I think it might be a good idea to now consult the schematics, because I think I do have the schematics sent over. Yeah, looks like we've got plus minus 15 on the op amps. Yep, definitely. Yeah, I bet all those little caps will be bad. Yeah, you're right. Probably will be. Right, let me see if I can find the schematic. I'm just going through my emails trying to find the schematics I think someone sent through. Boom or bust submissions. I can't remember where they sent it. Someone definitely did send me a schematic. But I cannot remember. Maybe if I have a look in here. I can't find it. I can't find it. Someone was like, yeah, I got the schematic here. It was in a live chat a few days ago. Bye, David. Thanks for jumping on. Appreciate you. Kind of running out of steam here. Oh, it was in Discord. David, thank you so much for that. Yes, it was in Discord. Literally. I never use Discord, so I would never have thought of that. Thank you. I've got to log in. I'm not even logged in. Yeah, okay. We're going to have the schematics here, guys. Don't you worry. Just give me a minute. We'll find the schematics. Where the hell is my private messages? Contact direct messages, is it? No, that was months ago. I'm sure I got a notification. I did get a notification on my Discord during the live stream. Direct messages. No, I don't have anything here. The last message I've got is in February. No, can't find it. Pending. There's no there's not like a spam filter, is there? Yep, no idea. Can't find it. But I definitely did get a notification on my phone. Frank has sent through some PDFs. Oh, nice one, Frank. Thank you very much. What have we got here? Schematic. Oh, okay. EPX2 schematic. There's a couple of ones. Oh, this is 98. What's the difference between 98 and 99? Maybe different revisions, possibly? 97 schematic. I'm going to go with a 99 schematic. Alright, so we're looking for where the signal goes after it comes out of one of the back pins of the main IC here. So let's try and find the main IC, the main processor. What are we saying? Here we go, LMC 1992, that's the one. Okie dokie. So yeah, outputs from here, like it's kind of these ones here, 18, 19, let L out, R out. Some bypass. Oh no, hang on a minute, these pins aren't in order. I thought they'd be in order of like where they were around, so I need to go ahead and count the pins. So got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's going to be pins 16, 17, 18, 19, 20, 21, 22, 21 through to like 21, 20, 19, 18, 17, 16. Right, it's 16 and onwards basically. So 16, 16 is RF out and RB out. Right, let's see where not those two, because those two have a very low signal on them. I want to go with a bigger one. 16, 17. What's pin 18? ROP. 19. Wait, 18 and 19 just goes through a bloody capacitor. Okay, fair enough. 15, 16, 17, 18, 19. Right, what's 19? 19 is that coming back in. 16, 17, 18, 19, 20. 20 is RTI. That goes round to something loop. I don't think that's right. That's not really an out. Oh no, it is an output. Loop out L. Loop pre TR TL. (16, 15, 16, 17, 18, 19, 20, 21. What's 21? 21 is L ret R ret. I assume that's like some kind of return. Although it's connected after the capacitors coming out at 20. Alright, I'm going to ignore those for now. The only ones I'm going to look at, just because they're the only ones that look like real kind of outputs that aren't complicated, is loop out L and loop out R. So I'm going to look for these and see where they end up. Oh, okay, yeah, we go into... Oh, wait a minute. No! That's just going to the bloody thing that I've already jumped, P5. No, I don't need to know that. That's not what I want to know. Hooray! Right, so the return. Right, the return is what comes from there. Fine. Where's the bloody output to the preamp stage? Huh? LF out, LB out, maybe? Here we go, we've got some outputs here. Left front out, left back out, right front out. Here we go, right, these are our outputs. 13, 14, 16 and 17. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, we have audio on 13, or this very low amplitude, and it's referenced to the negative DC. Okay, 13, 14, 15, 16, 17. Right, so I'm going to try and follow 16 and 17. So 16 and 17 I've got. So we go over here, we have continuity through C74 and C34. Let's find those. Oh great, they're not labelled on the board. The board doesn't have every component labelled. Love to see it. Okay, well it seems that those capacitors that it goes through, C74, C34, are in fact these ones over here. Okay, so we've got outputs here, 16 and 17, and we go into here, these capacitors, we come out of these capacitors, which gets rid of the DC, makes sense. Man, the signal is so low! The amplitude of the signal is so small, surely that can't be right. Do you know what I mean? Why is the amplitude so low? Anyway, I guess we'll just follow it through. So, yeah, these capacitors get rid of the DC. Okay, fantastic. This one here gets rid of the DC, and we left us with a little bit of signal there. Okay, cool. Where does that then go? That then goes into... what am I doing? After the capacitor, it goes into, we've got front, right and B FRBR is like a kind of output or input possibly. We go into a couple of, go into an LM833. A couple of LM833s, depending on what channel it is. And then after the 833s, we have RCA3 and RCA7. Okay. Well, RCA3 and RCA7 doesn't seem to go through anything else. Doesn't go through any further digital potentiometers or anything like that, no? Oh, we have J15, there we go. J15 is jumping the negative input from there to, okay, J15. Okay. I'd love to know what the purpose of J15 is. I wonder if the J15 jumper is bypassing... No, I was going to say... Yeah, no. I was going to say it might be bypassing like some extra processing, but it doesn't look like it. Right, let's check the 833s here. LM833. I'm just going to have a quick look at this 833. See if we've got any DC on it or anything. See if it's leaking. So we've got supply voltage on here. Audio there. Some audio there. Audio there. Supply voltage. Nothing. 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 Okay. And that is then supposed to be going to the RCA. So the issue seems to be that we have what seems to be an extremely tiny output from the processor. I'm just going to lift this jumper real quick, this J15. Just going to see how that changes the behavior of this circuit. Doesn't really seem to change the behavior of the circuit. Still got a tiny bit of signal on the RCA output there. Put that back in. Still got a tiny bit of signal. Ah, see, if I remove the jumper we get more signal on the RCA, but not by much, by like a tiny amount. Okay. What I want to know is where all of these other digital potentiometers come in. Because according to this, this connects the LM833 directly to RCA jack 3. Wait a minute, they all go to bloody RCA jack 3. What's RCA jack 3, RCA jack 7? They all seem to go there. From both LF out and RF out. Do they just combine at the RCA jack? RCA 7, RCA 3, RCA 7, RCA 3. Back right out, front right out, back left out. Back right, back left. Oh, I see. The RCA 7. Oh, of course. Stupid me. Silly me. Don't worry. You've got two RCAs, haven't you, on each block? Yeah, ignore me. I'm being stupid. So this is for front and back output. And it's just, yeah, it's just very low amplitude, but I don't really understand where all these other digital potentiometers and op amps are coming in. So let's have a look at the rest of the circuit and see if we can find them. So we've got this here, BL and FL. That's kind of injected at the same point as the output from the chip. So FL. FL goes over here, so we've got TL072, which is U52, which I don't think there's a marking for on the PCB. Maybe there is on one of the older ones. Nope. But I can check that with my multimeter. So we can have a TL072. Then where does that go? Does that go into? That goes into a Dallas, a digital potentiometer. That's what we're looking at here then. FLX O-min. Anything else? There's a couple of jumpers here for that. RCA 4. Okay, I think I get this now. So the all pass, the AP, the all pass is what's connected directly to the RCA terminals there. Yeah, okay, so for all pass, that's where it connects straight from the chip basically, and the high pass and low pass go through the digital potentiometers and the op amps by the looks of it. Okay, just real quick, let's have a look at these jumpers here. I'm going to remove both of these jumpers for a minute. I'm just going to shift it over to the other side. No, that hasn't seemed to make any difference either. Although now we have some RCA output on some of the other ones, which we weren't getting before. Yeah, okay, we've got some RCA output on some of the other ones now, but it's still extremely low amplitude, like probably way too low. I'm sure it must the output from this device must be higher than that under normal operating circumstances. Yeah, we have output actually from all of them anyway. Doesn't matter which way I have these jumpers in. Someone said it's those horrible metal capacitors. I don't think that they're what's causing the issue here. Because the signal is low coming out of the processor. That's the issue. Like, none of these metal capacitors here elsewhere on the board have the signal on them, really. Yeah, none of the other ones have the signal on them. Yeah, we've just got really low output from the chip from pins 16 and 17. Yeah, just got really low output from the chip, and I imagine that can't be right. Okay, I'm going to try looking at another one of these. I'm going to pull this one off the bench. I'm going to whack another one on and just see if there's any differences there between them, between the input and output from the IC. This was another one that we looked at previously here. This one though didn't seem to have any output from one of the original what do you call it? Digital potentiometers. Let's get this one powered up and have a look. Oh my god, that scared the bejesus out of me. Okay, so let's follow the audio signal through this one. I think this one, from memory, seemed to lose the audio signal here. Yeah, it doesn't come out of this, whereas on the other one it does. So I wonder whether the digital potentiometers here are bad. Okay. So yeah, this one we don't get any audio making its way to the IC at all. Seems to be some issue in the preamp circuit here. So okay, not that one then. The only other one that we've got is one that was pretty jank looking. Looks like it's been in a river. So I'm gonna take this one out of the case real quick and clean it up. Actually, the bottom looks alright. It just looks like the top that's had water on it. So I'm going to spray some isopropyl, get this cleaned up, just to see if this one's behaving any differently at all. We also need a fuse in there as well, which I'll be able to steal. One of these. Right, well this capacitor, actually looks like a bunch of these capacitors have all popped up. I'm going to leave them in for just for a minute. I'm just going to power it up and just see what the heck it does. It's been powered up before anyway, so no harm done. No extra harm done, I should say. But yeah, a bunch of these capacitors all look like they've gone pop. But I just want to see whether the audio makes its way to the chip in this one at all. These big capacitors here, these are all smoothing capacitors, so we shouldn't lose the audio as a result of them being popped. It would just mean poor filtering or something along those lines, so hello Big T, I'm good thanks, I'm not too bad. Been better, but I'm not too bad. Alright, I don't have very high hopes for this one because this one's very, very janky looking. But let's just see what it's doing anyway. Okay, this one doesn't seem to have any life at all. Right. Oh wait. Oh, it's like proper cutting in and out. It's trying. Right, there we go, it's working now, somehow. Right, 0.9 amps worth of current draw. Setup, we shouldn't have any EQ still, no, okay great. So, oh wow, we have a lot of DC offset on this one. It's all over the place. This one's very messy indeed. And actually on this one we've got the same amount of signal out as we did on the other one, just like really noisy because all the caps are popped. Maybe these things just have a super low RCA signal output then. But like it's ridiculously low. It's like so low you need like full gain position. This one was giving me RCA output even though I didn't have these EQ card jumpers placed, so that's a bit strange, isn't it? How are we getting some audio output from this one without these jumpers in place? I think these things are going to be a bloody mission. Like, it's really annoying because I don't have a working one for reference. If I had a working one that I could take reference from, that would be really useful because I could see, right, how much RCA voltage are we supposed to get out of these things? Like, yeah, it'd be really, really useful. But anyway guys, it's kind of late here in the UK now, so I think I'm going to lock the stream off here. It's been lovely hanging out with you guys this evening. I hope you guys have enjoyed, I hope you have learned something. And yeah, I hope you have a great rest of the day. I'll try and film a boom or bust as soon as possible. Try and get one out for this weekend, so look out for that. Yeah, have a great time. See you in the next one.